video where we are going to be building a real-time AI smile detection app in Python. I am Sonny, and today I am here with...
Aaron, what's up, guys? Remember me? I'm the Python guy, apparently.
Super pumped, guys. Super pumped for today. Aaron, what are we building today?
Can they see my screen right now? Or the
It
stream
should be
started?
coming through
Here,
now, yeah.
let me pause this. Mute this. All right, guys. So this is what we're building. I got my little app here, and I got a little face detection app.
Let me go ahead and share the screen one sec. All right, let's go. Yep, they can see you.
All right. Here's my face, and when I smile, it should be able to detect that I'm smiling, and then it displays. I mean, it's bugging out a little bit right now.
So go ahead and throw a smile. Hey, look at that.
There we go, guys.
And what we did, how are we getting that to work right now?
This is the code, bro. That's how stuff works.
So,
It's code right here.
what are we using?
But that's pretty much.
So we're using AI, right? And we're using what in particular to get that working?
OpenCV. So we're gonna be using the Open Computer Vision library, as usual. If you guys are watching the other couple streams in similar, but this one has some cool optimizations in the code. So it's pretty short. So it's pretty powerful library. I mean, what, 50 lines of code with comments and spaces. So
yeah,
pretty bite-sized, but you can do some cool stuff with it.
Awesome, dude. Yeah. Okay, so let's go back to us guys. There we go. Nice. So let's go ahead and see where everyone's at. Nice. We've already got 250 people in here. That's dope. Hope you guys...
Dang. Okay.
This is the first time, guys, me and Aaron are going live together, so this will be exciting.
Yeah, very first time.
Exactly. And also, guys, I'm not actually a Python developer, so many of you guys know me for React. So this will be cool for me as well. So I've never done machine learning with Python, so I'm excited for today. Yeah.
Let's go, Sonny.
Let's do it. So Aaron, let's go ahead and let's just jump straight in, I think, yeah?
All right, yeah. Let's get straight to the project, okay? So here's the stream. All right, got a little presentation here for you guys. So let's just start off to get a little bit of context. So smile detection with Python. All right. First of all, you just want to pay respects to the Joker himself, the infinite smiler. I mean, he's always smiling, but really not. The legend Heath Ledger. Rest in peace. Rest in peace, bro. But yeah, guys, just make sure you're smiling a lot because it's important. It's good for your mental health, and people will probably like you more, or just think you're freaking crazy. So how are we gonna do this? Sonny smiles a lot, I've noticed. So you can be blessed with his super white teeth. It's a British thing. Nah, you guys just misspell words. That's all it is. It's misspelled words. All right, so how are we gonna do this? So you guys guessed it. It's all things go to machine learning. Okay, all things go to machine learning. So we're gonna be doing that. We're not gonna be training anything, but we're gonna be doing some pretty crafty stuff in the app with some pre-trained models this time. It gets a little bit fancy here and there, but I'll explain how it's happening. So here's a quick code breakdown of our app. I just kind of want to give like the overall idea of the code logic, just so that people have some context going in before we start coding. Because I don't like when they just jump in. They're like, oh, what are we doing? But this kind of gives you a holistic view. So step one, the very first thing we got to do is find faces in our photo. In our case, it's going to be a frame from the webcam. That's what I'm going to be using in the app. But here,
awesome.
The first thing you want to do is you want to find faces, and that's using the HAR algorithm.
What is the HAR algorithm?
Yeah, so I'm not actually going to be explaining the algorithm in this video, but if you want to know how the algorithm actually works in depth, you can watch our face detection video or our car and pedestrian tracking video from a week or a couple weeks back. And in those two videos, I explained them in depth. Different explanations in both. At the face detection, it's at the end. And then the other video, it's at the beginning. But if you want to actually see how it works, you can go watch those videos. Those are cool. But this app's a little bit longer, a little more complicated, so I'm just glossing over it.
Okay, awesome. Also, I just want to say, so step one is find the faces. So at this point, we're literally just finding the face, right? So we're not actually finding the
smile. No smiles yet.
Okay.
So you want to find just the face like that. Yep. Step one. That's find the face. Very simple.
Yep.
And then we also want to crop it out just so we're dealing with this.
Okay.
Okay. Step two, We want to find smiles within those faces because I mean it's pretty rare you have a smile outside of a face. I mean maybe if you had like some dentures lying around or like a weird piece of art on the wall. But I mean 9 times out of 10, a smile is always going to be within a face.
Yep.
Okay. Again, this is the HAR algorithm. So again, if you want to see how it works, it's just generic object detection, but we can detect smiles within the faces. Okay. So we just
Awesome.
detect the smile there. Then step 3, all we need to do is just put the rest of the image back, get rid of that bounding box,
Yep.
and give it a nice little label on the bottom because this makes more sense, you know? I mean, you could have a box around the mouth. I guess that's kind of cool, but this is cooler because then you just kind of want to know if the face is smiling or not. It just seems more human. So that was the design choice there for the app.
Nice. So
And that's really it, guys. So
yeah, I noticed that you basically you found the face first, and then what? Then we
mhm.
found the smile within that box, right?
Yep,
And
yep.
then why do we
And
do
then
that instead of just doing the whole smile
you
screening?
you'll actually see once we get to there.
Okay.
A lot of AI stuff. You kind of need to get clever with the optimizing and layering different layers because
Yeah.
if we did smile detection just everywhere, the performance is actually really, really terrible.
Okay.
So I'll show you guys that. I'll show you guys that once we're coding, and then you'll see because it's actually pretty accurate. Like when I'm running the code,
Yeah.
well, here, so I actually ran it here on the. I mean, here it's a little bit bad because it's blurry and the lighting's bad, but I just wanted to run it on this GIF before to show you that it's kind of working. Like when he's smiling, you can kind of see it picking it up a little bit here and there.
Awesome.
But on the webcam, it was pretty accurate.
Nice.
So yeah, you'll see how ass the performance is if you run it on the whole thing. But there's a little trick to make it like really really accurate.
Awesome.
So guys, let's get to the code.
Yeah.
So
And
let's
guys,
get
if
out
you're
of here.
pumped for this, just all we ask is that before we get started, just smash the thumbs up button. What we got here? What was that, Elon Musk?
Yeah, I have the other from the car and pedestrian tracking. I just forgot to delete it. Anyways, um, yeah. So let's get to the code, okay?
Hey,
Real quick, guys, before we start
we
though.
just got a donation, dude, from Tushar Nearus. He says, character doing a shaka
Nice.
sign with his hand saying, cool. Oh, okay. No, he actually sent in something. We can't actually see it properly on the super chat, guys, but it's some guy waving cool. So thank you for that. Cheers.
Nice. All right. Real quick, Sonny. You want to show them the screen about the free training?
Yeah.
Mention that real
So
quick.
yes, let's do it, guys. So we have a free Python masterclass that I recommend everyone goes ahead and signs up to. I haven't actually got the link, Aaron. I've got profit with 1 second. Let me go ahead and show this. So guys, let me go. Do you mind just slacking me the link for the? Where's it going?
Yeah, or I can do it. Just share my screen and then I can go through it.
Let's do it.
Yeah.
Yep.
There we go.
There we go. Nice.
Can they see on
Yep.
my screen?
They got you.
Yeah. What's up, guys? So if you guys are interested in learning how to actually make a living from Python, then we have a free Python training here that teaches you the 3 secrets of how to become a Python freelancer. So link is in the description. You can click down there to check it out. Or if you just want to jump straight to our Python course, then we also have a course which teaches you how to do that as well. This is a paid course though, so if you're interested in that, there's also the link in the description. Okay, a lot of cool stuff in here: free trainings, private communities, weekly live calls with a couple instructors, and yeah, feel free to check it out. But other than that, let's just get to the code, okay, guys?
Also, guys, just want to point out one thing. With that said, the something that I really want to point out that I think is always cool is that we actually offer weekly live training calls in that program. So if you do want to go ahead and you get a bit bored of the sort of Udemy courses that you see online, then make sure you go and check it out. But before any of that, be sure to sign up to that free training, guys, because it's completely free. So you have nothing to lose. Go ahead and check it out
Yeah.
if you enjoy the video. Awesome.
All right.
Let's do it, dude.
All right, man. Is the focus back on my screen?
The focus is back on your screen.
Let's go, guys. Okay. So let's just jump right in, all right? So remember, we're going to be finding faces first, and then from there, finding smiles and
Yep.
layering it over. So this is the full app. Again, OpenCV, very powerful. We can do some stuff in a pretty short app. So first thing is, you're going to need to download a couple files. These are in the description down below. So you just go to those web pages and download these 2 XML files to start out. I'll explain this in a second.
Dope.
And once you've done that, you just need to make a Python file. So start with small detector.py.
Yep.
And actually, I think I'll just code in here.
Yeah, let's do that. It's always nice to see
All
a
right.
bit of fresh code.
Yeah. Oh yeah, of course. But I was gonna make a new file, but I'm not feeling it. So we'll just pretend this is a new file, okay? So just make a new file in a new directory.
We just got another donation as well. We got Vishal S dropped a 20 rupee super chat. Thank you very much, dude. And
Oh,
Tushar dropped another one. Thank you guys.
Tushar. Thanks,
Says,
Tushar.
thank you.
Shocked
Free
right back.
knowledge, everyone. Appreciate that, dude.
Much appreciated, man.
Yeah.
All right. So let's get started, okay? So first thing we're gonna need to do is install OpenCV if you don't already have that. So I think that is through the command. Well, let me quit out of this. There we are.
Hey.
Quit out of that. You're gonna need to install it from pip install opencv-python.
Okay.
Oh, it
I'm
might
new
be
to Python. So what
Python.
is pip? Firstly, like for those that are new
Oh,
to
pip
Python.
is
Yeah.
the Python. I forget what it stands for, but it's a package installer Python or something.
Okay. So it's
Package
like
installer
it's a bit
Python.
like npm then, right?
Yeah, yeah. So it just allows you to install a bunch of libraries that are for Python. So there's pip, there's Anaconda, there's Homebrew. There's a few you can use to download different things, but we're just using pip. It's the simplest one in my opinion.
Got
So
it.
yep, just run pip, and then this is a command install, and then we're going to be installing opencv-python. It might be python-opencv. Just try both, and
Okay.
then the one that works works. And if you're having issues with that, then adding headless at the end can sometimes fix stuff.
Awesome.
But yeah, just do that or do a Google search if you really can't figure it out. Once you have OpenCV installed, then we can start coding. Okay.
Yep.
So we can just import CV2. So that's the very first step. Is just importing OpenCVs. This 2 is the second version. This is the second version of CV2. I actually don't know why it's like that, but CV2 is the library for OpenCV.
Okay.
Okay. And let's just start with this just to make sure that our code is running correctly. So OpenCV2.
Yep.
I mean import CV2, and then it's big enough, right? Let me get rid of this
Yeah,
thing
we're
here.
good. Yeah. And that's how we run our Python script. We write Python with the file name .py, and that's it, right?
Yep, just make sure you're in the same directory. So in my case, I'm actually in a folder, and then make sure you're in a folder here. If you guys don't know how to do that, then I mean, yeah, I don't want to make this too much of a command line
Yeah.
thing, but
No, that's
cd
dope. Yeah.
is change directory.
Yep.
Yeah, so actually, let me just go back here. So see, I'm on the desktop here. You probably, well, actually, you'll probably be here when you open your terminal. It might look different, but you'll probably be one above the desktop. You're going to want to put cd and then just type in desktop to go to your desktop. I'm in the desktop. And then from there, you're going to want to cd to OpenCV. Well, this is the name of my folder. It's OpenCV file, smile detection.
Awesome.
And then from there, now I'm in this folder. And
Yep.
then I can run this command. Okay, because that's
Got
where
it.
the file is located.
Okay.
Yeah, people don't know. So smile detector.py.
Yep.
And if we run this, it should just print
Nice.
what's up, because that's all we have in here. Okay, so it's working correctly. That also means this is working correctly. It'll pop an error for you if you don't actually have it installed correctly, but this one, it just doesn't say anything. If it says nothing, you mean you got it installed correctly. If it says something, you got to install it correctly.
Got it.
All right, so let's just move on, okay?
Let's do it.
Let me pull some of this code from down here. So first thing I said is we're gonna actually start with just the face detection. So let me copy the comments as well, just so like we have a nice nice app with comments and everything.
Nice.
So face classifier. All right, so here, this is a pre-trained model for detecting faces. Like all the fancy machine learning stuff happens in here. It's just a bunch of numbers that the image gets passed through, and then it tells you face or not. That's all it is. You pop in an image to this, and then it says yes or no, and it gives you an answer.
Right.
Again, if you want to see how this is actually made, the whole algorithm and step by step with everything that's happening inside the computer, then you can go watch one of the other face detection or car and pedestrian tracking videos.
Yeah, I think it's worth saying.
But let's just start with this.
just like from my understanding, Aaron, like a classifier is something where we have like some kind of input, right? And then we have this model. So in this case, we have the Haar cascade frontal face. So some kind of like model is inside of that classifier. And then, so let me go ahead and I'm just writing on the screen. So we have some kind of model. And then from that, so we have some kind of input, right? Then we have a model. And then we have, one sec. and then we have some kind of output. And what would that output say? Would it like a certain value which says if you're smiling or not, right?
Yeah, literally just a 1 or a 0.
Yeah. Okay.
It'll
So in
just
this
say,
case, yeah, a one or
well,
a
yes or
zero.
no, but yeah, but well, technically, it'll give you coordinates on your image of where the box is around the face
Got it.
in practice. But I mean, basically, it just kind of says yes or no.
Okay.
Kinda. I mean, the implementation is different, but the idea is it'll just say smile or not smile. That's all it'll say.
Got it. So we have some kind of input, a classifier, which is what we're using here, which is that har cascade, and then some kind of output, which is whether it's telling us if it's smiling or not, or some kind of coordinate. But that's how it roughly works, guys. So as Aaron said, you pretty much this is the line of code to go ahead and get that working. Nice. Yeah. Carry on. Cool.
Yeah, actually, I guess I can explain a little tiny bit. Technically, if you have a whole entire image or a frame from a video, then it will look over every little box inside that, and then it'll tell you if each of those boxes of different sizes, if that's a face or not, or if that's a smile or not. So
Nice.
that's what it's actually saying. If it's a yes, it sends you the coordinates within the whole image of the little box, and then that's how we draw the little box because we have the coordinate, and we can just draw a box at that coordinate.
Got
So
it.
that's actually what's happening.
Oh,
So it's
nice.
the whole image, and then you just go over the whole thing, and then each is like no, 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 no. Oh, found a face. That's a yes. Give me the coordinate, and then no, no, no again. So if there's multiple faces, it'll find multiple faces as well.
Awesome. Okay,
So
so it's not just one
yep.
phase. We can support multiple phases. Oh, nice. Surab
Yeah, we can.
Khani just dropped a 100
Yeah.
rupee donation. Says thank you so much for sharing.
Nice.
Awesome. Thank you, dude. Let's carry on.
Thank you. Yeah. Here, actually, let's run the code really quick.
Yep.
I want to show it with two faces. I didn't show with two.
Oh, nice. Yeah.
I should have shown it with two real quick. I can just use my phone. There we go. Well, I mean, hopefully it works. It might bug out because one of them is an image.
Yeah.
But we'll see.
Oh, nice. That's dope, dude.
And it says smiling.
Yeah, and it's real time and it's quite performant. Like that's pretty like fast. Like as you move your phone around. If you try and move it around fast.
Mm-hmm.
Yeah, look at that. That's just smooth. Nice. Okay, and so there's some kind of loop I'm guessing that's running, or like some kind of thing that's gonna happen there. Yeah.
Yeah, we're just pulling out the. Let me clear this. We're just pulling out the webcam footage.
Okay.
Pulling the webcam. It's the easiest way to get some real time footage. Yeah, I mean, this could be a security camera, it could be a whatever, but in our case, we're just gonna be using the webcam.
Got it. Nice.
All right, so let's do that next. Let's just pull out the webcam and show you how to get the webcam with OpenCV. If you guys are watching the other streams, you guys know how to do this. You'd be very comfortable by now. This is the third time we're doing it, but let's just do this right there. And this is the best way to do it because then there's no typos and I don't embarrass myself. Right, Sonny?
That's the
Sure, that happens a lot.
yeah.
But anyways, so this is how you want to grab your webcam. We just call it webcam a variable. You're gonna need to have a variable for that because this is how we access all the webcam stream footage. But really, it's just video capture. So you just call the OpenCV library dot video capture, and then if you put 0, this is the webcam. But you could actually also put like something like whatever dot MP4.
Okay.
You could also get video files and run it on there.
Nice.
Like the Joker one that I had.
Yeah.
Over here. This is how I did that. I just imported this file and then I ran it through and then I recorded it and put it back here. But for us, 0 is webcam.
Nice. Go ahead.
So let's pop it 0. And let's just, I think it's CV.im show.
Okay.
No, not im show. Wait, what is it? I always get confused between footage and, yeah, it is im show.
Okay.
I always get confused between images. So yeah, show the current frame. So let's just pop in a quick loop and just show the webcam live to the screen, okay?
Dope.
And from here, and it should be, we should clean up. I think it's destroy all windows. Yeah, cv2 destroy and
Oh, okay. You have to release the webcam as well. Nice.
yeah, just clean. I mean, you technically don't have to, but I mean, it's just like good practice. So this here is what's actually going to show. So while true, we're just going to be showing the frame. Oh, I forgot another line of code. We're actually going to need one more. This is actually a big chunk size. Let me go line by line. Let me just get this last one here.
Yep.
Where the heck did it? Here it is. I'll read the current frame. All right.
Nice.
Let me go line by line because this kind of was a big chunk. So what's happening here is after we get the webcam variable, How we get a frame is we actually let me just show this real quick. So let me comment out all this just so that we can go step by step. Is a better way. Doing this on the fly, guys. So here
Nice.
we go. Look at this single line here. Ignore everything after that.
Okay.
Okay. We can. Okay, we'll do this. The way I like to do it.
Just have some
code completed. So if this prints, yeah, it means if it prints, then there is no errors because it's at the end.
Got it.
So this is how we actually read the webcam. So you call .read on the webcam, and what this returns is a tuple. So this is actually a two tuple. So this is the first one, first element. This is the second element. Okay, and oops. Yeah, what this is just a boolean of if it was a successful frame read or not, and the second one is the actual frame. So this is like an image that we can actually run things on. So let's actually just show that.
Okay.
Now I can grab the cv2.image show.
Got it.
Right there. And this is the name of the window. So I just put why so serious, but you can put smile detector if you want.
Yep.
Okay. And let's go back to the terminal. Oops. What did I do? There we go. Smile detector.
Yep.
And I forgot one more. So after this, you're going to need to run cv2.wait key.
Okay.
Right.
And what does this do?
Let's put this. What this does is, so what happens is we get the webcam.
Yep.
Okay. And then we call webcam.read, which is just reading from the webcam stream.
Got it.
And it'll get the first frame, the very first frame of the webcam video.
Yep.
And then if it succeeded or not, but ignore this for now. It'll get the first frame. Then from here, it'll say cv2.image show. Image show means it'll show that image to the screen.
Nice.
We're going to show frame and then the window name will have small detector. Like up here at the top of the window will be small detector.
Nice. Okay.
The thing is, this shows only for a split second as long as it needs to, and then it quits out.
Right.
What this does is it says, let's wait for a key before we continue to the end of the program. So it'll stay open until we press a key. Okay. This basically means display.
Right. Okay. So this means that without this line of code, it pretty much hides it super quick. So now it's saying wait until you press a key on the keyboard to hide it, right?
Yeah, pretty much. And this is here because once we're going frame by frame, you don't want to be pressing a key every time the frame changes. It's going to automatically change in real time. Okay. So we really only need this for this case of doing just the first frame, the image. So let's run this and see what happens. There we go. So that's the first frame.
Go ahead.
Okay, so like it's not an actual video, it's just one frame.
Okay.
But we're gonna wrap this in a loop and then we'll see it in real time. Okay.
Oh, I see. Okay, so you just got a single frame. Okay, I got you. I'm with you.
Yep.
Nice. Yep.
Yep, because .read will read a single frame. Okay. And then it keeps track of where it is. So every time it calls .read, it'll read the next frame, next frame. So we just wrap this in a loop, and that's how we can get the real-time webcam footage.
Right. So I'm just gonna write reads a single frame. Right. Read single frame. Oops. Single frame. Nice. Okay.
You taking some notes for them?
Yeah. There we go. Awesome.
Nice, bro. I'm running out of coffee. This is a disaster.
So this makes sense. Yeah. We're gonna read a single frame and then we're gonna wrap it in some kind of loop so we get that real time functionality.
Exactly, which is what we're gonna do down here. So let's get back to here now. But I'm just gonna plug in things one by one. So like I said, just the webcam, and then read a single frame, display that frame, and then display that frame. Like wait until a key is pressed before you hide the frame. Okay. So now all we want to do is just pop this in a loop. Okay. So we got the webcam here. Now, the loop is going to be here because once we have the webcam, we want to keep calling .read on each frame over and over again. Yep. Okay. So we would just want to run this forever, and that's why it's a while true loop. You just want to run forever until we're done. Got you. So let's pop all of this into there, and from here, let me get the cleanup code. Okay, so this here at the end, let me show you guys this real quick. This here is just some cleanup. Okay, so it's not super important. It's kind of boring code, but I'm just gonna say at the end of the whole app, you want to make sure you have a webcam.release. It's just letting the operating system know that hey, this app is done using the webcam. Free up all resources so that something else can use it, like Zoom or Skype can now use the webcam without any memory issues. Go ahead. And then, the last thing is CV2 to destroy all windows. So this just kind of closes all windows to make sure nothing's still open.
Okay.
Because sometimes that happens. Yeah, this is a cool little thing I forgot about, but I found recently, so
Nice.
very handy. Yeah. Okay, so after this, then we get webcam. We have a while loop,
Yep.
and same exact thing. So this should work. The only caveat is if this is empty, it's gonna keep waiting for a key press. So let's run this, and then I'll show you how that works. So here we go. It's a frozen frame,
Yep.
but as I press a key, it keeps going to different iterations of loop. So it keeps running. It keeps. Yeah, and each time I hit it, it gets the current frame because it's calling dot read. All right, so it calls dot read on the frame.
Yep.
Dot free, and if I spam it, and then kind of like real time, but that's annoying. So what we actually want to do is, dot wait key actually just waits until a key is pressed forever. But if we put something in here, this is how many milliseconds it'll wait before it automatically goes by.
Right.
So if we put 1, it'll automatically spam a key every 1 millisecond, and that's kind of like the behavior. If I put like 1,000,000, then it would just wait 1,000,000. That'd be too long. It'd be like 10 minutes.
Yeah.
But if I just put 1 millisecond, now when I run this should be updating every millisecond by itself, and it actually be in real time. So let's give it a shot.
Nice.
Well, let me quit out of the old one. Oh wait, I gotta kill it. 1 second. How do you kill it in
it should
ZSH?
It should be Control C. Yeah. So if you just spam Control C, sometimes it takes a little bit.
Oh, it's not working.
Oh,
That's okay. I'll just force quit.
Yeah. Also,
Yeah,
guys, just want to drop in while Aaron's sorting that out. We have one comment over there that says, Wamik Ajaz says, Bernath, you people are really amazing. Awesome. I have no words to express my feelings. It's only because of you people. Today, I got a job at Google.
At Google?
He got a job at Google, dude. That's insane.
Damn.
Like seeing that.
Holy crap. I couldn't even get a job at Google. What is... Bro, get this guy on the stream. He should be teaching, not me.
I know. That's
not
insane. We love that, guys. And we also got another donation from Tech Programmer. Yeah, thank you very much, dude. We massively appreciate that. And also,
that is amazing.
Guys, drop us questions in the chat, and literally we'll be happy to answer it as the stream goes on. We really love when you guys engage with us and let us know. Yeah.
Hey, whoever landed the job at Google, send me and Sonny a DM on Instagram, and then we want to hear a little about your story. That's awesome. That's exciting.
Yeah.
What was his name? Sonny?
What did he say? He said. Yeah. Let me go ahead and find it again. So.
What is his name?
It's.
I don't have it on. I don't have the stream open.
So I've just popped it open. It says Wamik Ajaz.
Wamik Ajax. Got it. All right, Wamik. Yeah, we'll be expecting you to DM us. Okay.
Yeah. Awesome. Reach
just
out
say,
to us.
Just say I'm the Google guy.
Yeah, I'm the Google guy. That's insane, dude. We love that. Nice.
Kind of jealous, actually.
Yeah.
It soured my mood. Nah, man, that's amazing. Great. That's exciting.
We have another awesome comment by Sayatan Bakshi. He goes, you guys are just amazing. I've learned a lot from these live stream. Your work is very inspiring. Thank you so much. That's awesome, dude. Thank you for watching. All right, let's carry on.
All right.
Let's carry on.
Yeah, it did. The Control C didn't work, so I don't know what's happening, but I just killed it manually.
Yeah.
So where were we before I got distracted? Oh, I was running the frames. Yeah, so when I run this again, it should actually refresh every millisecond by itself. Okay, so that's how we fetch this. So let's run this and go back here, and there we go. So I'm feeding the webcam footage. OpenCV is getting the webcam footage, the webcam stream, and then it's just displaying it in this window. And then I called it smile detector.
Right.
As I
so that by putting 1 inside of the wait key, that's pretty much saying every second, like go to the next frame, right?
Yeah, like it says only wait for 1 second. It says wait for 1 second, then press a key like a fake key, like a pretend key, and then it presses a key every 1 second.
Got it. Okay.
So this waits 1 millisecond.
Yeah.
But nothing waits infinitely.
Nice.
So that's the difference.
Awesome.
Or 10. We could even do 10. 10 milliseconds is fast, so this would still work, but it doesn't really matter.
Awesome.
All right.
Yep.
Nice. And okay, let's see if it'll kill. Okay, so now Control C is working. Nice. Yeah. I don't know what this red thing means. Sonny had me install this weird shell thing, ZSH. I've only used it like once, but I ran away. But he says it's colorful.
Yeah. So. Usually, I think that's when your branch is dirty. I think so. I mean, That's usually when you're in it,
Got
or
it.
something like that. Yeah, yeah.
Got Yeah, I probably changed the code in here and then it changed. But no big deal. Just ignore this, like the color of the arrow.
Cool.
But yeah, let's just move on, okay?
Got it.
So I can actually get rid of this stuff because we actually pulled everything out. So now we're back to the um, code ran without errors.
Nice.
Okay. Here, let me just pop in some comments for
Also,
anybody
guys, we
jumping around.
have 350 people
Current
watching
frame.
right now. So thank you so much for watching. And yeah, if you're enjoying what you're seeing right now, with the face detection, you think it's pretty cool, all we ask is that you just smash the thumbs up button, and that will help this video get out to more
Yeah.
people. Nice.
Yeah. Yeah, like smash the trackpad, like slam your mouse, just
Yeah,
hit
like
it as hard as you can.
beat that thing.
Domestic violence in the software programmer's house.
Exactly.
Stop the, that's a terrible joke, but uh, so yeah, this is step one. All right, so we got the webcam footage in here.
Got it.
You guys should be comfortable with this if you guys done this before. Pretty straightforward. Now, one check we want to put in though is actually this. So, I mean, it wasn't breaking before, but we do want to put in a check here, right here. So after we read the frame, okay, the first frame with the dot read method, the first variable, or I mean, the first element is actually a boolean of if the read was successful or not.
Okay.
So all I want to do is put yeah, because sometimes it might bug out. With the webcam, it's usually fine, but for a video file, if you're reading in an MP4 or something, like if you put a video file in here, like sometimes if one of the frames is corrupted or whatever, then it'll not work. So you just kind of put a safe check in here. So
Got it.
if it wasn't a successful frame read, just break out of this while loop and just like abort the program, and it'll go down to here and close everything so that it doesn't break. It just kind of quits.
Awesome.
So yep, that's all that is. Just a quick
Nice.
little.
Aaron, somebody asked a decent question here. They said, "How can I install the face XML file?" So the one that we used at the top. Where did you actually get that from again?
The OpenCV GitHub repo. So they provide all of that. The link is in the description, so you can just go down and scroll all the way to the bottom and just download this the face XML file. There's also a Smile one, but we haven't gotten there yet. We're going to be using both. We need both to make this work. You guys will see later why that is.
Yeah.
But
Awesome.
yeah, let's just continue.
Let's do it.
So after we get the frame read and we have this little check here,
Yeah.
then let's actually start detecting faces, okay? So if you guys watched the face detection video, you guys already know how to do this. Pretty straightforward. It's very similar, but there's a little trick here that you guys are probably going to blow your minds at some point, hopefully, but maybe not. Okay, so after we got the frame, to actually run face detection on the current frame using this XML, we need to use, we're using OpenCV, of course. It's a very simple code. It's just like detect faces pretty much.
Yep.
But we do need to change the frame to black and white though. This is just an optimization because in a black and white image, you can still tell what a face is. You know, if a human can still tell, then a computer can still tell, and then there's less data to deal with. But the actual recognition ability of face isn't hindered by it being black and white. So we just convert it to black and white to greatly optimize it. It increases it by a lot actually because RGB has 3 channels, black and white only has 1 channel.
That's super interesting. I had no idea that would be an optimization. So we're making it grayscale so that it actually reduces like the sort of the amount of processing that it has to do on the video.
Yeah, because you're kind of just like jumbling RG and B together into one number, red, green, and blue. Because then you can just kind of be like, oh, then you can just play with brightness. You can be like, okay, somebody's eyes look a little bit darker than their bright cheeks, something like that.
Oh,
and,
I see. Nice.
Or somebody's eyebrows are darker than their forehead. You just want to see the relationship of brightness between different areas on the thing, and those all added together, if you do it enough, you'll eventually define a face. Like, okay, eyebrows darker than forehead, eyebrows darker than nose, lips a little bit darker than cheeks, eyes a little bit darker than cheeks, stuff like that. Like hairline a little bit darker than if you have dark hair. So like it's just those kinds of things over and over. You eventually can explain to a computer what a face looks like after thousands of those little relationships.
Got it.
Or a car, or a pedestrian, or anything, or a smile in this case.
Awesome.
So like teeth, you know.
Yeah.
Teeth are whiter than your lips, so like it would understand what a smile is.
Nice. Okay, that's awesome. I would never have thought that would be optimization. So that's cool. Also, just to jump in, Chinmoy Kalita says again, because of you, I'm able to make my college fees by freelancing. Just wanted to throw that in.
Dang,
I love stuff like
dang,
that.
these people.
Thank you, dude.
I feel like these people are making more money than us. Like, I'm kind of upset.
I know, guys. I think you
Nah,
guys should start
that's
running these.
amazing, you guys.
Yeah. Amazing.
We're helping a guy make money so he can go to school to learn from people that are not us. Is that
Oh
is that
yeah.
actually a win for us, Sonny? Is that actually a
I
win for
know,
us?
right? Let's think about this for a second. I think we should cut the
Hmm,
stream.
we can't abort.
Yeah.
Like,
Nice.
cut all signals, Sonny. Cut it.
What I love though
But
about Python
anyways,
is that is this like literally so few lines of code to get this all working.
yeah, that's what I love about it too. And then if you optimize everything under the hood, which is how
Yeah.
you should be doing stuff, like if you use like C or C++ under the hood, then it's still pretty fast, but you can be very expressive with your stuff. I think that's why they choose it for machine learning
Yeah.
because there's a lot of weird, yeah, there's a lot of weird, nasty stuff. And you'll actually see the power of Python here later on.
Nice.
If this was written in JavaScript, it'd probably be like 2 or 3 times as long, you know? Like,
Yeah,
I mean,
100%.
maybe
Definitely.
not.
Yeah. I can vouch for that. Yeah.
Of course.
Yeah. This is
Um,
nice and clean compared to JavaScript. All right, let's carry on.
yeah, I don't like JavaScript.
Yeah.
Yeah. I know, no, JavaScript is amazing, Sonny. I don't want to hurt your feelings. I know
It's gonna make me hulk out, guys.
JavaScript is
You might just see, you just see a
yeah,
video feed
yeah.
reconnecting.
Oh.
Nice. Let's go.
Sonny's the Hulk. That's his nickname. Um, but yeah, let's continue on. So once it's gray, okay, this is actually a requirement. Like OpenCV, you have to take it. And so, oh, I should explain how this. So what this is OpenCV has a function called convert color, which just allows you to convert the color of an image to black and white, or back and forth, or just the red channel, or just the blue channel. You can do all different kinds of things. But in our case, we just want to change something from a color image to gray. Okay. I mean, well, this is BGR, which is RGB backwards, and then to gray. So that's all this means. There's like different encodings we can use. So we're going to be using this one to convert this from a color image to gray. So let's actually run this now.
Go ahead.
And well, actually, we need to display the actual black and white frame. I feel like I've done this a bajillion times because I actually have. It might be boring some people who've seen the other streams, but whatever. And there we go.
Oh,
Black and white webcam. Yep. So you can still tell that this is a face. You can
yeah.
still tell that my mouth is smiling. So we
And
don't need
dude,
color to be able to
already
identify stuff.
it actually
It's black
looks
and
a
white.
bit smoother. It actually looks a bit smoother when you
It
do it,
is
huh? Yeah.
because there's only a third of the data. You know, with color you have 3 channels or 4 channels actually. There's a brightness channel as well.
Yeah.
But on this one, it's just the brightness channel.
Nice.
That's it.
But
So it's actually 4 times as fast because there's 1 channel versus 4 channels.
awesome.
And let me just quit out on the terminal. Control C. And let's just clear this up because it's getting messy.
Nice.
All right. So there we go. Black and white frame. Now it's literally as simple as popping this grayscale frame into our classifier for faces.
Yep.
And it'll spit out the coordinates of where my face is. And then we can just draw a rectangle over my face. And bada bing, bada boom, that's a face detector.
Go ahead.
That's the first step. And then we got to do smiles. You have to like overlap them in some weird way. And there's some cool there's a little trick I'll show you guys later that is critical for this to work. And then some tuning. You have to tune some variables at the end too, which actually make it work properly. But
I love how simple you make it. It's like, yeah, we just got to use this machine learning classifier, and then, gonna get some coordinates back, and then we just got to draw a box around the face. Yeah, no biggie. You got to do that, and you got to have an infinite loop. And
I mean, I'm explaining every line, so I feel like people can follow along if they know Python. If not, then I'll fire myself.
Yeah.
Donald Trump's.
Nice.
Yeah. So let's go down here and actually just detect faces, okay?
Let's do it.
Pop here. I might go a little bit faster because I'm just kind of this is like repeating the face detection stream.
Yeah.
We haven't even gotten to the smile stuff yet, but here's the line for detecting the actual faces.
Okay.
So, yep. So how this is gonna work is we have our classifier up here, okay, face
Okay.
detector, which we created from this XML file, which has like all the data about like what a face actually looks like, depending on the brightness relationships, like we talked about.
Okay.
Like, and then from there, so we have this face detector.
Yeah.
Now with this face detector, okay, with this face detector, we can call a function called detect multi-scale.
Okay.
Okay, and then it just takes in an image, and then so what this will do, it will tell us where all the faces are in this image. Okay, it'll say, oh, there's a face here, there's a face here, there's a face here, and
Okay.
that's what it'll do.
So
Hmm.
is it returning an array?
Yes, an array of points,
Okay.
an array of rectangles.
Got it.
So the reason it's called detect multi-scale is because you just want to detect faces of any scale. So if there's a small face, you want to detect a small face. If there's a big face, you want to detect a big face, and you want to detect multiples of them. So you detect all of them. That's why it's called detect multi-scale. Because we can really pop in, we can use any detector, like we have a dog detector or a cat detector. We could also detect multi-scale of cats or dogs.
Okay.
So that's why it's called that.
Nice.
Hmm.
Okay. Got it.
Hmm. So it takes in a frame, a black and white frame, and then it'll say, okay, at these places there are faces in this image, and that's what this is. So this is just an array of points.
Yeah.
In my case, it's going to be array of length 1 because there's only one face. But when I had the Joker on the face, when I had Joker on the screen too,
Yeah.
and let me pull up real quick, then there would actually be, so when there was both of us,
Yeah.
then there would be, this faces would be of length 2 because there's two faces in the in
Yeah.
the video.
Got it. Makes sense.
Okay. Yep. So from there, let's just print out actually faces. Okay. So
Yep.
this is just going to be a list. Let's just show this, and it's going to spam the terminal here over and over again because we're in an infinite loop. Remember? So as I'm here,
Oh, nice.
you can see the location of my face is being detected, and then it's just being spit out here.
Okay.
So this is like XY coordinates, like blah blah blah.
Yeah.
And then from this, we can just draw a rectangle on the face. That's it.
That's clean, man. I was expecting like some really intense stuff, but that's super clean how it comes back. Like, nice.
Yeah,
Yeah.
that's it. So it's a list of lists. So if there's two faces, so actually watch this. Now there's two faces.
Hey, look at that.
See how there's two faces on the screen?
Yeah.
And then when I get rid of it, we're back to one face. The list is length 1, now the list of length 2. And
That's
there's 2 per.
awesome. That's nice. Okay. Got it.
And if there's 3, then 3. If there's bajillion,
Yeah.
we're in the Matrix, Mr. Anderson. A bunch of agents going.
I think it's
So
worth
let's just
saying,
find
guys,
that.
that like just from like that classifier, you're able to do all of this. So this is just the power of machine learning. Like, and as
Yeah.
Aaron said, this is a face detector, a human face detector, but you could easily go and pick up like a dog detector, put that here, and I guess it would do the same thing, right?
You can detect anything. So Har Cascade is a single algorithm that can detect any arbitrary object. So basically, you're like, if the computer was a person, we're literally downloading this is what a face looks like into its brain. That's literally what this is doing. You just have to teach this before we give it to it. So this was a result of machine learning with a bunch of face images that somebody created, and it takes probably like a few hours or a few days to create it. But then once it's created, then anybody can use it. So that's kind of the power of it.
Awesome. Got you.
Yep. And of course, Har Cascade is just one algorithm for object detection, whatever object happens to be, in our case, a face or smile.
Yeah.
There's many algorithms, but this is the simplest and the oldest one. It's actually based on Viola Jones. These names probably mean nothing, but if you want to look up Viola Jones algorithm,
Yeah.
and then Har Cascade. So these are just names of people who came up with them back in like the 70s or 60s or whatever.
Nice.
But
Awesome.
smart people. Yeah, very smart people. So, okay, so that's the face. So from here, we just want to draw those rectangles back on the image
Okay.
here, and then when we show it, then it'll actually have the rectangles drawn on this as well, instead of just showing just the raw frame.
Okay.
So that's really all we're doing.
Nice.
Then from there, then we can get to the smile stuff. So at this point, we probably should have said at the beginning, oh, if you want to get to the smile part, just skip ahead, but it's too late. This is a stream
Yeah.
for anybody watching the replay. But
I mean, I guess
it
like
is what it is. Free
yeah, at
content.
45 at point 45 minutes or so, like that's when we start the smile stuff. So yeah, we can add that in the comments afterwards.
Yeah, let's put the timestamps, and then we, like the YouTube has that thing now where the play bar is like segmented. That thing, mind
Yeah,
blowing.
exactly. Yeah, that's insane.
Bro, you
That's
should
nice.
do that. That would be a cool clone to do. You should be like YouTube, segmentation clone. Like you scrape out like the stuff and then you
Oh
segment up the
yeah.
video or
Oh,
something. I don't
that
know if you know
would be
what that is.
cool. Yeah.
That'll be
Nice.
sick. All right, stay tuned tomorrow for that because
Yeah.
Sonny's a beast. He can code things in 5 minutes.
Wait, guys, just as another reminder, so we actually have quite a few people on this live stream right now. Tomorrow, if you're
Do
excited,
we?
we are building a WhatsApp clone. So we are building a WhatsApp clone tomorrow. It's going to use Firebase. It's going to have a real-time
Yeah.
chat functionality. So if you're excited about that, smash the thumbs up and make sure you set a reminder for
Uh,
tomorrow. Yeah.
have you coded iMessages yet? An iMessage clone?
No, that's a good idea. Yeah, we'll do that as well. Yeah.
You should do that because you did Facebook Messenger, but you should do iMessage too instead of WhatsApp.
That
But
would
I
be
mean,
dope.
WhatsApp is more international friendly.
Yeah, we
Yeah,
can just do
bro.
that. Hey.
Forget the Android people. All right.
Oh,
Okay. So now what we want to do is we just want to run. We just want to draw some rectangles on the frame. So I'm going to kind of go over this quickly. If you're getting confused, then again, the other videos go a little bit slower to explain this in detail, but I'm just going to go a little bit faster, okay?
let's do it.
Because we're going a little long here, longer than I thought. It's already been an hour, bro.
Yeah.
But so all we're going to do, like I said, faces is a list of points.
Yep.
So we just want to iterate over all of the points. So all of the faces that the algorithm found, it's just going to have lists. Let's just iterate over all of them and pull out those points. So like I said, there's 4 points here for each face. So we're just going to iterate over all of them, okay?
Go ahead.
So the first point is x, the x coordinate. The second point is the y coordinate. This is
Okay.
the top left point of the face.
Yep.
And then this is the width, and this is the height of how big that square or rectangle should be. So for a face, it's squares by default, but for smiles, it can be any shaped rectangle. So it just gives us like the width and height of the rectangle. So we're given a point and a height. From there, that's all we need to actually draw it, because we can just say at this point, go this far and then go down, and you can figure out the rest with math, which is what we're going to do here.
Go ahead. Okay. Nice.
So here, CV2 allows you to draw stuff on frames.
Yep.
So like this, we can draw rectangles. We can also put text on the screen, which is how I put the smiling little thing
Yep.
when it says smiling. So you can also put text. We'll do that later. But for now, we're just going to draw a rectangle.
Go ahead.
So the way this works is you just give it the image you want to pop it on. So
Yep.
in our case, we want to draw the rectangle back on the colored frame, not the grayscale frame, but the colored frame.
Oh, I see. Okay.
Because we're only doing the calculations on the grayscale frame, because the coordinates and everything is exactly the same. But once we have the data of where the face is, we can just use the color again.
Got
So
you.
it's an optimization. Yep, because you're doing the calculations on the black and white image, but then we're actually still only seeing the color image, which is what you want.
Okay. Got you.
And for rectangle, all you need is the top left point and bottom right point of the rectangle for it to draw, because those 2 points, it makes it easy to draw the rectangle.
Yep.
So the top left point, like we mentioned, is XY. That's
Okay.
what we have here. Then the bottom right point is just going to be XY, but you add the width and the height to the correct coordinate. So X, you want to go an extra width, because that's the width of the rectangle. You just add W to it.
Okay.
And then Y, you just want to add the height to it. And those two together will be the bottom right point of the rectangle.
Oh, okay.
If you guys don't know this, then just like look at your geometry. Yeah, brush up a little bit.
So
But
that's X
that
plus
should,
width and then Y plus the height, and that'll give us the square, right? Like the rectangle, sorry.
Yep.
Yep. Go ahead.
Yep. Square. In our case, it'll be a square. But any rectangle, you can draw any rectangle.
Go ahead. And what's the numbers on the right? So what are these?
This is RGB, the color of the rectangle.
Okay.
Well, technically BGR, because it's backwards in OpenCV.
Yeah.
This is just a random color. You can put whatever you want. You can play. These can go from 0 to 255.
Okay.
You can use whatever color you want, but I just chose this as a nice green color.
Nice.
Okay, because like it kind of like it matched nicely with the Joker screenshot. So this is just a random green color. You can use this if you want, but yeah, use whatever color you want. Then this is just the thickness of the rectangle.
Okay. Nice.
So 4 pixels thick. That's all.
So-
So this is just like customization stuff.
This one line is gonna draw the rectangle on that frame.
Yep.
Oh,
Yep.
damn.
It's gonna draw on that frame. Well, a single face on that single frame.
Yeah.
So we're gonna draw all the faces on the frame. Then we're gonna display that frame.
Nice.
And then on the second frame, it'll detect all the faces in the second frame, and then show all the faces in the second frame.
Right.
And then again, third frame, because we're in another loop. So this is a nested loop.
Yep.
And then there's going to be another nested loop within this one, which is going to be crazy later on. But
Yeah.
so we're going to have three
Let's go
nested
ahead
loops.
and run this to see if we can actually see the rectangles that you just talked about.
Yeah, definitely. So displaying the colored frame here, which is what we drew the rectangles on, colored frame.
Yep.
And let's just run this. As we can see here, this is the X point, this is the Y point,
Yep.
this is the width, and this is the height.
Nice.
And faces are always squares by default because that's just the parameter they set. So you can see the width and height is always the same. See?
Nice.
Width and height is always the same, but different sizes sometimes because detect multi-scale, it can be smaller or bigger.
Okay. Awesome.
Let's run this, and there we go. Magic.
Oh snap, dude. That's insane. In JavaScript, that would be like 30 lines of code, you know, just to get
Yeah,
that kind of thing
yeah, I
working.
know.
Yeah, it'd be something.
We know.
Yeah, this is
We
where
know.
like I really do come back to Python a bit and like, whoa.
Yeah, man. You can do web development with Python too. You don't actually need JavaScript. You can just use Django or something.
Oh, gonna start a war now, dude.
I'll fight you and Nas both.
Yeah, you might have a green circle around your face, but you're talking to the Hulk.
Hulk, yeah, with no legs, right? There's an ongoing goat, guys. I think we should just tell the community. Like Sonny's good at so much stuff. So when he joined the team a few months back, I was like, one day we're on a team meeting. I was like, "Yo, Sonny, you're so good at everything. There has to be something effed up about you." But he lives in UK. We're all in Los Angeles. So Kazi was like, we've never seen Sonny's legs, and we're like, he must be in a wheelchair or something. Like, there's something there.
Everyone thinks
Uh,
I don't have
It's
legs.
bad about people in wheelchairs, but yeah, it's just a joke because we've never seen his legs, so he's always insecure and showing his legs in the video chats. Like,
Yeah, but
bro,
guys, at least today, I'm not the only one wearing a black shirt. So you know
is that a thing? Are you always wearing a black shirt?
that's always a thing, dude. Everyone's always like, "Yo, Sonny doesn't have any other shirts besides black t-shirt."
He's so shirtless.
Steve Jobs wears a whole what's it called row neck.
Turtleneck, right?
Yeah, row neck, and then they're like, Sonny wears a black t-shirt every single time.
Zuckerberg wears a blue T-shirt, right?
Yeah, like a gray t-shirt. It saves you time in the morning, guys. So that's why.
Technically, this is dark gray. It's not black, so you're still by yourself, Sonny.
Oh shit.
But anyways, let's get back to
Let's get
this.
back
So
to
that's
it.
the face detection app. I basically just repeated the face detection video, but whatever. So now, that's pretty good. So like, wouldn't a smile detector be as simple as just changing this out for a smile and running the same thing?
I would
Well,
think
yeah,
so.
let's
Yeah.
try that. I mean, you would think so. You would think so, but you guys are about to see some really, really weird crap, and then really, really cool trick to fix that weird crap,
Let's do it.
which is interesting. It's a smart thing to do. So let's create our smile detector, okay?
Yep.
So did I spell smile correctly? Yeah.
There we go.
Smile detect. So same exact thing. We're gonna be using hard cascade and to detect faces, but we can also use it to detect smiles.
Okay.
So in this case, there's another file in description. It's just called hardcascade.smile, I think. Let me double check down here. Yeah, hardcascade_smile.
Yep.
And we just use this pre-trained classifier instead. So this took a bunch of images of people smiling with their teeth showing. It doesn't detect like regular smiles that good. It's mostly like teeth smiles from the training data, but you can teach it to do both. But in our case, you kind of have to show your teeth for it to work like really well.
Got it.
But that's there. So why don't we just use this instead of the face? Like, because it's detecting the face so well, right? Like it was tracking my face perfectly, and if there's multiple faces,
Yep.
shouldn't it be able to detect smiles too?
Yeah.
Supposedly. So let's go down this code and make the changes. Okay, so we get the webcam.
Okay.
We want to iterate over every frame. We want to read every frame in each iteration, and then our little check, and then frame grayscale. So we get the current frame, we change it to grayscale. Now, instead of detecting faces, let's actually detect, smiles. Okay.
Nice. Okay.
Detect smiles, and instead of on face detector, let's call smile detector, and we want to call it on the same frame, so grayscale frame.
Yep.
And then again, let's just copy this exact code, but instead of And we can use the same variables because this and this loop will never overlap. Like this loop will completely finish before this loop starts, so we can use the same variables, which is fine. Just to
Okay.
keep it nice and clean looking.
Yep.
There's no, if it was nested, we cannot, because then they would get they'd fight over the variables. But loop completes before this even starts, so it's okay to use the same variables here.
Got it.
But instead of faces, let's draw smiles. Okay, so now this is going to be, so this is what it's doing is the same exact thing. It's going to find all the smiles in the image and then return a list of points, the exact same thing. Upper left hand point here, and then the width and height of the smile. In this case, it's going to be like a horizontal rectangle instead of a square.
Okay. So it's returning the same thing, right? The same coordinates, the same format we saw earlier. Okay.
Yeah. Yep. Yeah, it's going to look just like this, but instead of giving us the coordinates of faces, it's going to give us the coordinates of smiles.
Got it.
It's like just a different rectangle on the image. It's smaller around the mouth, and it's like horizontal looking.
Got it.
Let's change the color though. I had a this color.
Okay.
It's the color I chose. It's like a nice red color.
Yeah.
And because right now it's the same color as the face, but I want to change it to this red color.
Got it.
Like I said, BGR. So R is at the end. That's why it's so high. So it looks more red because the R channel is the highest.
Got it. Okay.
Red. So let's run this, and let's actually not draw the faces. Let's just get rid of the faces. So I'm not even going to draw the faces.
Okay. So we should just see
only
the
smile.
Okay.
Yeah. So not even faces. It should just have things of smiles on my face.
Right.
Okay. I mean, it should just have rectangles around the smile on my face.
Yep.
So let's run this. And
whoa!
Voila! As you can see, it's working perfectly.
Holy crap! Okay, so this is what this is what you meant by it's just a lot.
It doesn't work for shit.
Yeah.
Yeah, it doesn't. It does not work, but it does. And I'll explain that in a second and how that actually works. But as you can see right now, the default, it's like this isn't even working properly. Like what the hell? Like how? Like okay, it's actually getting my smile. Look at my smile.
I was actually getting the smile, yeah. Nice.
It's actually getting it, so it's smart enough to find it, but there's a lot of false positives.
Right.
Like it thinks this stuff over here, like this little windowsill is there because it probably thinks this white is like teeth and this is my lip or something. Yeah. But I mean, there's also getting things here on the freaking curtain which make no sense, you know, like what? I mean, this may be a little bit too. Like it looks like the upper teeth and the lower teeth, and the little gray line is like maybe the gap between the teeth a little bit. Like you can kind of understand.
Maybe we just built a ghost detector or some shit, you know? Like
yeah, that's what they said in the face detection video or the pedestrian tracking. But
yeah,
point is, this is working like ass. Okay.
Yeah.
So how do we fix this? It's like this isn't even working. First, let me explain why this is happening. So there's probably a couple reasons why I see what this is happening, and I'm gonna explain both.
Okay.
First thing is, so let's just quit out of this first. So why is this performing so shit?
Yeah.
I realize it's swearing screen. It's fine.
It's fine.
First reason is, to be honest, faces are one of the very first things that people detected from the beginning. That's like the very that it's like the coolest thing to detect to start with, and has like a very defining feature. Like detecting squares or detecting a soccer ball is kind of like, okay, it's kind of cool, I guess. Detecting a face is like pretty cool. Right. So there is a lot more data in this trained algorithm than there is in anything else. So there was actually just more face data, and this was just trained better than Smile was to begin with. So that's the first reason why face detection was working so well, because it ran on more data for longer, while this one probably didn't get much data.
Nice.
Okay, just because, yeah, it's like, okay, if you want to have like a left fingernail detector, like there's not going to be as much data as faces, just because faces are cooler. Or like a blade of grass detector, like who codes that? Yeah, you don't want to take a vigilante.
And also, guys, like if you think about it, a face has so many features. You have like, you have your eyes, you have loads of things which basically are going to tell that model that, okay, we can be sure that that's a face. Whereas a smile has a lot less to look for. Like you just have pretty much like the curvature of your smile. That's why it can easily get confused. Like the lamp behind Aaron has like a little curvature to it, so it could get confused thinking that's a smile. Whereas a face has several different reference points that it will look for in terms of features. So just something to bear in mind as to why you would get that.
That was the second point I was going to make. You stole it out of my mouth. But that is absolutely correct, guys.
Yeah.
It's exactly what I was going to say. Is there's less features. Like detecting a tooth is much harder than detecting a face, because how do you detect a tooth? It's just a flat white thing with like a specific shape, but it's harder to detect.
Yep.
Like it might get a tooth and a marshmallow mixed up, but it wouldn't get a face and a marshmallow mixed up unless you're the Michelin Man. But or the Pillsbury guy, you know, the little
Yeah.
bakery guy. But but yeah, that's the point that Sonny made. Right, that's the second point. So first one is face probably just has more data overall, just because it's a more defining object and it has more emotional connection to humans. So it's like, cool, let's detect faces. But also, it just has more data that it can go by to determine, hey, is this a face or not? Versus a smile, you're kind of limited.
Nice. Got it.
Hmm.
Cool, man.
So that is absolutely correct. So that's why it's performing like ass. I mean, it could be better. It could be better if they trained it better with more data.
Yep.
But even then, it's still harder to detect than a face.
Right.
So how do we get around this? Well, um, first of all, there's different parameters we can tune. So you can actually be like, hey, if something only counts as a smile, if there's like two or three things around it that are also a smile, because then it kind of thinks, okay, if this area kind of has like 4 smiles detected, then it's a smile. But if it's just one random thing that might kind of be a smile, but there's only one instead of like four,
Yep.
then you can be like, okay, that's not a smile enough. So like there's kind of like a redundancy.
Okay.
Code one more time, explain that visually.
Got it.
So like here, we're just getting a bunch of stuff, okay?
Yep.
So but you can see like there's random one over here, just getting they're blipping up every now and then.
Yep. So are you trying
You
to say like
can get rid of those.
right? So in a simple sort of like in a one sentence sort of answer, like rather than checking the entire sort of webcam view, we kind of want to narrow down that sort of selection down to just your face, right?
Not quite there. That's the other optimization I'm gonna show. But
Okay.
what I'm saying is, see how there's like random boxes showing up over here,
Yeah.
like by themselves? We can kind of get rid of all the standalone ones that just kind of flash really quick.
Okay.
But if there's a big group, yeah, if there's a big group of boxes overlaid on top of each other, though, we can kind of say the chances of that actually being a smile is a little bit higher. Like up here, we could maybe boil this down to like one smile. We could be like, okay, there's freaking 7 boxes here. This is
Yeah.
probably a smile. There's 7 here. This is probably a smile. There's a bunch here. This is probably a smile. But these little ones on the sides that are flashing randomly, we
Yeah.
can say, nah, we don't want those,
Right.
and
So
we can actually get rid of that.
is there some kind
Mhm.
of sensitivity or
Yep, that's all it is. It's just a sensitivity number, and you have to tune it to faces. So you find the perfect number, which I'll show you guys in a little bit. But we can actually do that. So let's add that in.
like
And you won't see that much of an improvement here on this, but I'll show you guys um, the second optimization, which is going to clean everything up and make it go from complete ass to super, super accurate, which is pretty impressive.
nice?
So um, detect. So this happens in the detect multi-scale. Okay.
Yep.
So there's two different things called, or two different parameters you can use called min neighbors and scale factor.
Okay.
Okay. So let's get these
Yep.
up here. Here we go. So this, and let me actually type it out. So this is going to be scale factor.
Okay.
I think I might have spelled it. And then this is going to be min neighbors.
Okay.
It might be the wrong spelling, so it might not work, but let's just try it. So what this is going to do is it says scale factor. This is an optimization to how much you want to blur the image, because if you blurred this image, you can still kind of tell it's a face if you don't blur it too much.
Okay.
And then if you blur it, that's another optimization on top of the black and white. Okay, you can kind of like generalize, and then you can kind of compare the data a little bit more.
Okay.
Because there's less data, but you can still kind of tell it's a face. So you want to kind of optimize this. Basically, this scale factor is blur. Like how much do you want to blur the image to make it easier to detect faces and kind of like get the defining features and brightness, or not. So the higher this number, then the more it'll get blurred. So I found that 1.7 is the best.
Right.
Then
So just to
Mhm.
just to be clear there, so you're saying essentially to blur the sort of the entire frame, so that way it will be easier to detect facial features as opposed to like a curtain or like a lampshade.
Yeah, because you get a lot rid of a lot of the details, which are unimportant. So like if there was like a 4K image and there's a lot of details, then it can get very confused with the data. But if you blur it enough, you can kind of, if you blur it like a crap load, you can kind of be like, okay, there's kind of a blurry face in the middle, and then everything else is just like a blurred mess in the background. So it actually kind of like contrasts like the objects. You can be like, okay, there's a face, and then there's a bunch of blurred background. You can't even tell if it's curtain or wall or whatever, but you can kind of be like, okay, there's a face here.
Got it. Okay, nice.
So that's the idea. If you can blur it down more, you can actually detect faces even better.
Yep.
Then min neighbors is what I was just talking about. There has to be 20 neighboring rectangles in total in that little area for it to actually count as a smile.
Okay.
So if this was 1, then literally just everything would be passed through. But if you make this higher, then it's like, okay, there needs to be a lot of redundant rectangles on this one little area for this to actually be a smile. So it's like it found 20 smiles in this little region of the image. Because they're all overlapping, it has 20 neighbors. The minimum amount of neighbors of a rectangle needs to be 20 for it to actually be counted as a smile. So this will help a little bit.
Yeah.
Let me show you guys. And then, well, actually not even at all. Like, well, actually it helps a lot.
Oh, one sec.
More than
Go
before.
Back. All right. So there we go.
All right.
Yep. We're back.
There you go.
Whoa.
So as you can see,
okay,
it's actually better. A lot better.
That's a lot.
But I mean, there's still a little. Yeah, there's still a few things. So here, yeah, I don't know why it's so fixated on this light. To be honest.
Yeah.
Like, it's probably thinking that this is teeth. It's probably looking for like a horizontal line of white. So it's thinking this is teeth.
Okay. That way, I mean, like you can see why the lamp. But I mean, the top left is a bit of a weird one.
Yeah, but I mean, you can kind of see like this little white oval, and my teeth look similar.
Yeah. So it's probably trying to find like teeth and then the curvature of your mouth. Okay. Got you.
Yeah. So something like that. So that works really, really well. So like a lot of fine tuning needs to be done for things to work properly. Yep. So just that little change there, that worked way better than when I was testing it. But I mean, that's amazing. So tuning different numbers can actually play a big role in that. So like maybe like in a real world application, if you're detecting smiles, you would want to save these numbers. Okay. And be like, okay, for smiles, always use these parameters. This is like additional machine learning on top of all the crazy numbers of machine learning that's in here. You have this plus a little bit more. So this is kind of like manual machine learning. You manually went through and tested a bunch of different sensitivities, and you used your eyes to be like, okay, this is actually machine learning. So that you actually taught the computer that these two numbers are closer to a smile than anything else. So this is like manual machine learning that you're doing.
Okay.
Pretty cool.
Yeah. Nice.
Okay. Now going forward, another optimization that we can do is actually get rid of these errors, because like Sonny said, and what I said in the slides is smiles only show up in faces.
Yeah.
So why don't we, instead of trying to get it across the entire frame, just find a face and then only run smile detection within that face?
Yeah.
Because we already did the work of the face detection. So why don't we do that?
That's awesome.
And that's what we're gonna do next.
Because
it makes it faster and more accurate.
Yeah, when I first thought of it, I kind of thought that like, oh, we're just gonna slap a model on the entire webcam and it'll figure it out. But guys, you have to be prepared. Like, take it in mind that you there's a lot to process in. Remember, in the beginning, we said like you pretty much have some kind of input, your model, and then some kind of output. So if you can reduce the amount of input going into the model, you can actually speed up the entire thing a lot more. Like, and it's drastically going to be faster, and it's also going to be like more reliable in terms of we're only going to select Aaron's face and then find the smile inside there. So something to better.
Yeah. On the self-driving car live stream we did, the car and pedestrian tracking one, you can see a really good example of this in real time. When we were doing it, because there were so many cars on a highway, so some highway footage, there were so many cars and a lot of pedestrians, because here you're only detecting like 2 or 3.
Yeah.
But in those, there's like 10 cars and 20 pedestrians, so it was going crazy. When you do that one, when you scale it down, so if you blur the image more, it's faster. If you make it black and white, it's faster. And then some other optimizations, you can actually see the footage gets played back really, really fast. So that's a good visualization if you go check it out. Go watch that stream too. It's nice. It's badass as well.
Yeah, go check that one out, guys. I'm gonna watch that one as well after this.
Somebody's not watching my content.
Yeah, no, I do. I'm the guy smashing the dislike. I'm joking.
Wow. Okay. So Sonny woke up this morning. He was like, "Aaron, I'm really grumpy. I don't want to do the stream." And I was like, "Bro, I need you. I don't have my internet sucks. I need you, man." And then he's like, now he's all in a better mood because he's been hanging out with me. So
It's fun,
the
dude.
whole
We'll definitely do
ingredient.
some more streams. Yeah, this will be cool. We can even probably do some kind of Python React, like hybrid.
Yeah,
Yeah,
dude, let's do that. We could like tie it together, like do like a cool front end app with JavaScript, and we can have some cool like back end Python stuff like happening like this,
yeah,
like a front end thing where you click like smile detector, face detector, like car pedestrian detector, and have like you pick like different files and it feeds it in,
yeah.
something cool like that.
Exactly. That'd
But
be awesome. Aaron, quick question here from Shantao. He says,
yo,
"Is it beginner friendly?" So just maybe a quick answer to that.
is this video beginner friendly or is the other ones beginner
Yeah,
friendly?
like just for anyone that's new to the video or who might have joined afterwards, is this video beginner friendly? Like, do you need to know Python before you do this?
Yes, you need to know Python, but if you know like for loops and all the basic Python stuff and how to like call functions, then no.
Yeah.
I teach you the rest from there, but you do need. I don't teach the basics here, so you got to go learn the basics, then you can come back. If you're a complete from zero beginner, no. If you're just a beginner who knows Python but you haven't coded much, then yes, you can go through this
Yeah, and
step by
also
step.
just worth mentioning, guys, I don't code much Python, but I know JavaScript. So coming to this is actually super, super simple in terms of how Aaron's broken it down. So if you have any coding experience, then yeah, you can do this. So definitely go ahead and do it. Yeah.
Very straight. Awesome. So I popped back in the faces, so let's do this now. Okay.
Yep.
Let's go back to the terminal and run it again. And now we should have error. Oh, because I commented out faces. So it's giving me an error because I'm trying to use faces here
Yeah.
when I commented it out. Let's just get rid of that and run it again. So there we go. So we got the faces here and the smiles.
Nice. Hey, look at that.
Yep.
Awesome.
But I mean, it's still getting this. You want to get rid of all these random ones. So
Yep.
what we can do, like I said, is we can actually just run smile detection within this window instead of the whole frame, which is a smart optimization because, I mean, in the real world, you wouldn't see a smile out in the middle of nowhere unless it was like a piece of art or like dentures or something. But generally, smiles only show up within a face. So that's why we can do this.
Nice. Okay.
Yep. And then I'll actually show the effectiveness of that too. I'll get rid of these tuned parameters and actually show you how well that works.
Okay. Yeah.
I mean, it kind of works well, but these scaling factors, the sensitivity plus that little trick together makes it super accurate from what we had before. Just like freaking
Yeah.
rectangles all over
It's
the
like,
frame. But just a single smile,
yeah.
like we tune that down from just two little things. So
Nice.
it's like really smart, clever things to make your code work. Using something that doesn't work and making it work just
Yeah.
with a few numbers.
Awesome.
Yeah. So let's continue, okay? So how do we actually make it so that we only check within a face if there's a smile, okay? So like we said, we're in the global loop here that is looping over the entire frame. We read the frame. So from here, we keep going down, blah, 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 and then we get to faces, okay?
Okay.
Oops, run small detection within each of the faces. Run face detection. So some of these comments might have not made sense the entire time because I kept
Yeah.
popping them. So this is what I had before, run face detection. But now we want to actually do this within each of those faces. This is what we're currently going to be installing. So how do we do that? Okay, let's look at it just from here. So we're in the frame, and then we find all the faces, and we
Okay.
have all the boxes of frames. So we have the box of a face. So we have the box of what a face is, and
Yep.
we draw that box, right?
Okay.
But we have this box, so this is actually the box we want to look at. This is actually the sub image of the whole image that we want to find smiles in. We're actually given it right here.
Go ahead.
So we can actually just be like, okay, instead of looking at the whole frame, just look at this rectangle for the smiles instead.
Okay.
And that's what we're going to do. So how do we do that? There could be multiple smiles within a face though, right? I mean, not technically, but if there's errors, like it might detect like a little before your mouth. So you just want to make sure you find all of them. So what we're going to do is we're actually going to have another loop in here. It needs to be nested because within a face, you have to find all the smiles.
Okay.
So we're actually going to need to find the XY width height of each smile within the face. So same thing, we're just nesting it. Okay, does that make sense so far?
Yeah.
The
Quick
thing is
question.
though, because yeah,
Quick question. This is a Python question. So you have Are your variable names not going to clash here, or is it going to be in a scope?
They will.
Okay.
No, they will. They will.
Right.
I believe I'm 99% sure. I didn't even try because I thought they would, but I'm pretty sure they will. So what you can do is you could use like capital letters or something. I believe it's case sensitive.
Yep.
But you probably don't want to do that. What I did is just a little sloppy, but I just did this.
Okay.
Just so they don't contend, but it keeps it simpler. Because if you start doing stuff like this, the code starts looking really hard on the eyes.
Yeah.
Because this is so clean, you know, x, y, x plus w, y plus h.
Yeah.
You want to keep it nice and clear. But if we started doing this, then it would look like, you know, freaking x smile plus y smile. Like,
yeah,
it starts looking like that.
Yeah.
So, yeah. So I just did this. Just it's a little bit messier, but it's still easy to understand. I just added an underscore to the end.
Okay.
Okay. So we're going to need to look over the face. Okay.
Okay.
I mean, I should probably talk about getting the subset first. Let me go over the logic first. So what we want to do is you want to find in the face. Okay, so you want to find all the smiles in the face.
Okay.
So find all smiles in the face. Okay, so this is what we're going to do. This doesn't exist yet, but I'm just using this as a placeholder thing for right now. This code will not work because it's currently broken. Yep. And then just draw all the rectangles around the smile. Okay?
Or the rectangles.
Just like that. Right. Oh, shut up, dude.
Must be an American thing.
Okay, let me...
Yeah.
So let's just do this so it doesn't break. Oh yeah, I was making fun of your spelling before, right?
Yeah.
Oh god, that's hilarious. That backfired, didn't it? Anyways, so this is the kind of idea. We're gonna iterate over all the faces, and then within each of those faces, we're gonna find all the smiles. Okay, and then we just want to draw the rectangle in there. So kind of similar to what we did here, actually. Okay, the only caveat is you have to change the names here.
Yep.
So why don't we do that actually? Let me just copy this down here. So this is the same exact code as we had before. We just want to draw a rectangle around the smile.
Okay.
Okay. And then instead of X, Y, W, and H, it's just going to be this. Okay. Just add the underscores to the end.
Okay.
It's kind of hard on the eyes, but if you space it out like this, it's not too bad.
So just to bring everyone to speed, right now we had an initial loop which was going through all of the faces, and then so that was the first one on line 28. So I was going through all the faces, and then on line 34, we're going through the individual face that it detects, because you might have more than one face, and then we're drawing a rectangle around that individual face, right?
No. Within each of those faces, you want to find all the smiles and draw a rectangle around all those smiles.
Got it. Okay. Got it.
So what we're going to want to do is we're going to want to actually not run this here. We're going to want to run this. Oops. We're going to want to run this here.
Okay.
Okay?
Yep.
Well, actually not here. That's incorrect. But I need to explain something else first.
Where do we get where do we get the face from? Is that like placeholder for now, or
that's? Yeah, I'm about to explain that. This is the tricky part, and this is the really cool part. So let's just pretend that the face equals this for now. Okay, this code doesn't actually work, but this is what it is in flavor. Okay.
Yeah.
Just pretend this code does not work. This code does not work, but this is the idea. We want the face to be this little mini sub image within the whole image, because this is the current face, like the little square that surrounds the face. So we want this to be like a little image. But the thing is, you can't just pass in like these detect multiscale and get the smiles out of it. So we have to do some crafty stuff here with the array and slicing. But just this is the idea. Is that clear, Sonny?
Yep. Yep.
Okay, so if it makes sense to you, then hopefully it makes sense. You're
kind of putting it into an object, right?
Kind of. Well, what we're going to do is we're actually just going to slice into the image and get like a sub-image in some cool way. I'll show in a bit, but I just want to show the overall logic first before we do that.
Yeah, no worries.
Yep. So let's walk through this again. So yeah, we have all the faces here. Then we draw the rectangle around the face. Then we say, okay, get this little square image instead of the whole frame. Just get this little square. Now within this little square, use that to detect multiscale. So we want, instead of looking at frame grayscale, we want to actually look at the face.
Okay.
So let's, of course, we have to go to grayscale again, though, for the same reason. We have to convert this face, because if this was a color image, then we would need to change the face to a black and white color image. Like, actually, let me show you here. This is actually a good thing. So I said step one, okay, we want to find faces in our image.
Yep.
Okay. Then step two, get just this, so that we don't have to search the whole image. Instead of searching the whole image, we're only going to search within this face.
And we're doing
so now this is
we're doing that because we were getting like random sort of findings outside the face,
yeah.
right? Yeah. Okay.
Yeah, we're kind of just eliminating everything outside of the face
Yep.
as automatically no. Even if it says yes, it's going to say no, because we know that smiles only show up on faces.
Right.
Okay. Then step two, we find smiles within those faces, so we're only going to search within these bounds. And then at the end, we'll do a nice little labeling that we haven't gotten to yet.
Got it. Okay.
But yeah, so the idea is the face, this is going to be this.
Okay.
Okay, so this is frame, this is the whole frame, this is the face.
Got it.
Okay, so we need to get this, but it's still color, so we need to make this black and white as well, just the same as the other image.
Yep.
So let's go back and call, where is it? Let me just copy, paste this. And change it to face grayscale.
Okay.
So face grayscale is going to be the face. So same idea here. We have the face, the colored face, but now we want to change to black and white. So we use the convert color function again.
Okay.
And we pass in the face, the color face. We say change it from color to gray.
Okay.
And save it as face grayscale.
Right.
Okay. Then now in the smile detector, now instead of detecting it on the whole grayscale frame, let's only run it on the grayscale face.
Got it. Okay.
Yep, right there. And now this should be working, but the only caveat is this doesn't exist yet properly. This doesn't actually work. But this is the general idea. So once we have this, then we can run the smile detector only on the face there.
Okay.
And then we can draw all the rectangles around the smiles within that face after we find the coordinates of smiles. So it's actually going to be smiles.
Right, I'm with you.
Now this should be a little more clear.
Yeah.
Awesome. Great. So yep, find faces, draw the rectangles, get the little face, change the little face to grayscale, run smile detector on that little face, then draw all the rectangles on that little face.
Got it.
And that's how we're gonna get this kind of behavior. Okay.
Awesome.
So you can see how there's no red boxes outside of the face. It's only within the face.
Yep.
Yep. You said yep like a bajillion times on the stream, bro. Yep.
All right.
Yep.
I was gonna say,
Yep.
but the one thing I'm kind of confused on. So we have the okay, no, I see now, because you're doing it on face grayscale, and then that's where smiles comes from. Okay, no, that makes sense. Cool, got you. Yeah.
Mm-hmm. So yep, you're running smiles on the face. You're not running smiles on the whole frame.
Yeah, that's where I was a bit lost.
Yeah.
Right.
So that's there. So this should work in theory, right? But the thing is, this doesn't work. So how do we do this one little line of code? So this is a little tricky. I'm gonna have to explain it, but it actually is just a one-liner. We can actually achieve this, but I need to explain how it's done. And there's some weird details that I'm gonna explain.
Cool.
So let's get rid of this. Okay, run small detection with each of those faces, because we actually just copied that from over here. We just added the underscores at the end, so we don't overlap with the variable names.
Got you.
This remains unchanged. We still want to display the current frame and the wait key of 1 millisecond, and then release everything at the end, yada yada. But how do we do this? Okay, so we have the frame, right? We have the overall frame, but and then we also have the face, X, Y, W, H.
Yeah.
So how do we get a sub image of this whole image? Like if you have a big image, like right here, you have a big image, how do we find this sub image?
So
How do
you're
we
kind
get
of saying
just
like,
this?
how do I cut out just that image, right?
Yeah, cut out that image.
Right.
Um, there might be like a sub image function OpenCV, but I didn't want to do it that way because I wanted to show you guys this smarter way of doing it,
Okay.
or maybe a more efficient way. It's a little bit different. So, are you guys familiar with slicing in Python? I mean, if you know the basics of Python, okay.
I mean, I'm new to Python, so even if you run through that, it'd be kind of cool to see.
Got it.
Yep.
Okay, so let's look at this little environment here. Let me open up a Python environment completely separate. You start Python, and this is Python 2. It's fine though. Python 2 is fine.
Okay.
It's the same thing. So let's say we have a list, okay?
Yep.
And let's just call it um, list. Let's just call it L. Okay, whatever. So we have a list.
Let's call it colors.
Of
In colors.
I'm trying to think.
Or people.
Yeah. Colors. Let's do colors. Let's just do red, blue. Blue, green, yellow, black,
Got you.
white. That's good. Okay, so we have six colors here. Okay, this is a good length list.
Okay.
And let's hit enter. Red. Oh, because it needs to be strings.
I was just wondering.
Hello.
I was like, can you do that in Python? I wanted to see if you could do that. Yeah, nice. Okay.
1 second. Yeah, little mistake there.
Right.
There we go. Okay, now we have a list of strings.
Colors, plural.
Got it.
Yep.
Colors.
Nice. Okay.
There we go. So now we have our list. Okay, we have a list called colors, and it has all these in here. Now, as you know, we can index into colors with a 0, and we would get what, Sonny?
You'd get the red.
Absolutely.
Yep.
And we can index at 1
Blue.
to get blue, and 2 to get green, so on and so forth. Okay, so we can index. Pretty straightforward. In Python, you can also slice.
Okay.
So you can get, instead of just indexing at the first one or just the second one, you can actually get a subset of it. You can get like the first 3.
So you could say
And
like from point 0 for 2 points forward from point 0, get me like red, blue, green or something like that.
Exactly. We could get like just these 2, or we could get just these 3, or we could get just these 4. It's called slicing because you can slice up the list into like some you can trim it to whatever you want.
Okay.
So the way you do that is you use a colon. Okay, you put a colon here, and then you just put the first and the last. So very simple.
My God. It's so nice in Python, dude.
I know, man. That's why JavaScript sucks.
Slicing in JavaScript is a little bit more confusing, but yeah, that makes sense. Got you.
Yeah, that's all it is. So what this is saying is, in colors, give me the sub list from 0 to 3. So it'll have red, which is 0.
Yep.
It'll have blue, which is 1. It'll have green, which is 2. And it won't have yellow, which is 3. So it includes the first one, but does not include the last one.
Right.
So it's going to give us element 0, element 1, and element 2, but not element 3. So 0, 1, and 2. It should give us this as a list when I hit enter. Okay. Yep. Red, blue, green. And when I hit it, that's exactly what you get. Okay.
Nice.
That's how you slice. Of course, if what is this? So 0, 1, 2, 3, 4, 5. If I put 5, it would ignore white. So let's try that. It would give us everything except for the white. But if I put 6, okay, then it would actually, which doesn't exist, then it should give us all of it. Or it might break. Let me see if it breaks. No, it doesn't. So there's a safe check. So 6 goes past here, and it'll give you everything up to 6 because this is 5.
Nice.
Alternatively, because this is the maximum list, you can just not give it, and it'll just say 0 to the end of the list.
Oh, nice.
Okay. And vice versa, you could even be like beginning of the list up to 4.
I've seen that in a tutorial somewhere. That's nice. Yeah. Awesome.
Yep, you can just do that. So this is like 0. This is the same as saying 0 to 4.
Yep.
Cool stuff like that. One more cool thing I want to teach you guys is you can actually be like from 0 to 6, and you can actually add another colon, okay? And what this is the stride. So if you put 2, it's going to skip every 2.
Oh.
So this would actually give us red, stride of 2, instead of, if it was stride of 1, it would give us every 1, but stride of 2 will give us red, and then skip 1, then green, skip 1, black. So this should give us red, green, black, okay? There you go.
That's insane, dude. I love that.
right? Right?
Yeah, that's nice.
Um,
Yeah.
it's cool. So red, green, black. And again, if I put a stride of 3, it would jump in groups of 3. So it would go red, skip, skip, yellow, skip, skip, nothing. It would just be red, yellow.
Got you.
So let's try this. There you go. And
Awesome.
then again, if you did stride of 4, it would go red, skip, 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 black, skip, and then nothing else. So this would just be red, black.
Nice.
Boom.
So guys,
So
like
that's how you do that.
that's something new
Slicing
even
in
for
Python.
me, like slicing
Yeah.
in Python. So if you guys found that useful, what can they do, Aaron?
They can send a money request to my no request to my PayPal. Yeah, send a money request to my. Nah, you guys can smash the like button. Show us if your minds are blown. Just show us. Tell us in the comments, or if I'm being boring and going over basics. But
I
oh yeah,
I
guys,
think that's
if you,
awesome, honestly, because like I didn't actually
it's
know that you
clean.
could do that in Python. So awesome to see how you do that. Nice.
And we're not even done yet, bro. We're only halfway there. Well, look at this. Watch this.
Dope.
So this is called striding. This is called slicing. The first colon is slicing. The second colon is called striding because you wanted to define your stride.
Okay.
You can be like, if a stride of 1 is the same as not having a stride at all,
Yep.
and if you delete it, like having, like we said, it's like having nothing there.
Got
It's
you.
1 by default. The cool thing is you can also reverse a list by using negative numbers. So now, instead of going from 0 to 6, you'll go from 6 to 0. And this will actually reverse the whole list.
No way. Wait.
Oops. Um, let's try this. There we go. So now it's reversed.
What?
Here, let me actually explain that. So
Yeah.
actually, this didn't work. I made a mistake there. So 0 to 6,
Yeah.
this determines the direction of the stride. So it's still going to go from index 0, which is red, to index 6 or 5, which is white. But it's going in the
Oh,
right direction.
should you have
So
done
you're
six
starting from
zero?
0. Exactly, bro.
Yeah.
Exactly. Should have done 6, 0 because negative means you want to go in the left direction. So you want to start from index 6, which is really, well, actually, that's incorrect. You want to start from index 5
No.
because remember, the first one is inclusive.
Yeah.
So you want to start from index 5. It'll include it and it'll exclude this last one. And
Kodeep Joshi actually pointed that out in the comments. Nice. He goes, also that reverses the list. Nice. Yeah. Awesome.
yep. So if you did that, then it'll go through. The reason this isn't going, the first one red at the beginning is getting deleted. Remember, blue, there's supposed to be a red at the end, but it's getting deleted because it doesn't include 0. So you could technically put -1, okay? And then, okay, it doesn't work. But I mean, I thought it would. But if you just if you just omit it and don't have it there at all, then it kind of says like to go from the beginning all the way to beginning, but don't stop at 0, go like 1 further.
Okay.
So this is kind of similar to like not like when you omit it, you just kind of like go to the end when there's
Oh, yeah.
not a number there.
Nice.
So this would be reversing the list.
Dope.
Reversing the list. I've been talking too much. 1 second.
That's
I
really
got
powerful
hiccups.
though. That's massively powerful because even in JavaScript, like to reverse a list, you can do. I mean, there are tricks around it, but it's not as clean as that. Like that's really nice. Yeah.
Yeah, so Python makes it nice for like dealing with complex problems, which happens a lot in machine learning. You want to be able to express these ideas really simply. So this looks simple, but when you have to do like crazy slicing and like 7-dimensional arrays on like different images of like things, this adds up quickly. So it's difficult in Python and impossible in JavaScript. So that's why Python is the best, Sonny. You can cross over.
Oh
Which
man, if we do a collab like a React Django, it's gonna be like
it's
some
gonna be bickering the whole time.
fist fight. Like ES6 is better than this fucking slicing shit, bitch.
That's what I thought, bitch. Um,
Nice,
but yeah, so that's slicing and striding and using negative strides. Okay, so very cool there.
nice.
Um, so we can do that, and then of course we can omit both of them. And by default, because it's negative, it'll just start. Because it's negative, it'll start from the rightmost spot and go to the left. Because negative means going to the left. So this will also work for reversing a list. So this is how you can reverse any list in Python with one little line. So you have colors.
Yeah.
And then you have colors at -1. So this and this are reversed.
Got you.
Cool stuff.
Awesome.
Now I'm going to talk about slicing multi-dimensional arrays, which is what an image is. You can actually slice an image by using the same thing and just get a sub multi-dimensional array from that big array by using the same thing.
Okay.
So that's why this is relevant. So let's say you had um, a multi-dimensional array, because this can be kind of hard to explain visually with this example. Uh, okay, let's quit out of this. Okay, clear, seller, clear, and then let's go back into Python. Let's have a multi-dimensional array, okay?
Yep.
And let's have 1, 2, 3, 4. Okay.
Yep.
5, 6, 7, 8.
So this is one array with 3 arrays inside of it so far. And 4.
Yeah.
Okay, we got
And
4 arrays.
13, 14, 15, 16. So this should be like a it's gonna be kind of hard to do it in here. Could you have like a new line on here? No, you can't.
I mean, if you log it now, if you do M array.
Actually, let me I kind of want to explain this. I don't want to start editing stuff in here because it might get confusing.
Yeah. Also, guys, I just wanted to say we just are nearly about to hit 800 likes. So massive thank you, guys. And if you haven't already, smash a thumbs up because Aaron's about to drop some knowledge on Python tricks and tips. Nice.
Holy crap. Actually, let's just try to jump into the code. I feel like people probably understand slicing enough at this point to like translate over the ideas. Like I don't want to drag on too long because I spent 20 minutes explaining slicing.
Yeah.
So this is the goal. We have a frame. We have a face in that frame with our coordinates. How do we get this as an image of here as a sub image? Well, we can just use slicing with these numbers to slice a portion of this frame, which is just a multi-dimensional array. Okay. And that will actually give us an image instead of just this point, because all we have is points, and then we're actually drawing a rectangle on it ourselves. Up here, we're just drawing a rectangle around it, but we actually want to get like the full image, like all the pixel data of this bounding box.
Okay.
So the way we do that is, instead of doing it this way, we actually want to have the face be a slice. So what we want to do is we want to take the frame.
Yep.
Okay. And for a multi-dimensional array, you can actually slice in both dimensions. So what we could do is we could be like, okay, from 0 to the end in the x dimension, and from 0 to the end in the y dimension.
Whoa.
Remember how to slice?
Okay.
So this will just say get the whole frame. This is actually the same thing as representing the whole frame, because from 0 you're getting every single column and every single row and every single column. I'm getting the x and y confused. I gotta double check which one is which, but we'll try both. And we'll learn together. Okay. We're fresh together. But one is x and one is y. And of course, if you had like a three-dimensional thing, then you could even slice it in 3 dimensions. Like if you had a cube, and then you want to like find like some subset, some cube in there or some rectangle inside there, you could also slice that way. Okay. The idea is this: 0 to the end and 0 to the end. This will get us the full frame. So you can probably see where I'm going with this. All we really need to do is just utilize these 4 numbers to actually define the exact frame, the exact subframe of the full frame that we want.
Okay.
Yep. And so that's really simple. I mean, all you want to do is just slice. So where do we want to start? So from the beginning, the top left corner of it is going to be x. Yeah. Okay. And then x plus width.
Okay.
That's it. And then in the y direction, we're going to have y and y plus height. That's literally it. Okay. So we're going to slice this whole frame and get the subframe of x plus w, and y plus h. But I'm pretty sure this is backwards. I think y needs to come first. I think I just eliminate something. So I'm pretty sure y has to come first. And then, of course, if we had a z coordinate as well, you would want to do like z and then z plus depth or something. But we don't have this. We're not doing crazy like 3D modeling here. We're just doing images. But I mean, I'm just showing here that you can do this. One thing I do need to point out, very, very, very important, is this does actually not work. This does not work in vanilla Python. Oh, the reason this does work is because OpenCV is built on Numpy. And Numpy, this works. This works in Numpy. Numpy is a library for dealing with numbers and matrices in Python, very powerful, and it allows you to do cool stuff like this. but this is not in vanilla Python. So that's why in this terminal, it wasn't going to work, and I didn't want to explain it here because this wouldn't actually work. You would need to import NumPy, which is just NumPy like that, okay? I mean, I guess I could have defined it here. So let me actually show this a little bit.
Yeah, because I
So
kind of get it, and then there's a little bit of a gap. So yeah, it'll be handy to go through this. Yeah.
yeah,
Got it.
I think it's like a pretty print in NumPy.
I think it's isn't it? Oh, printf is variables. Isn't it?
Yeah, what is it? What is the NumPy nice print method? How to pretty print a NumPy array without scientific notation.
Also, for
Print
those of you
curious.
asking if this live will be saved, yes, this will be available afterwards. All of the live streams are available afterwards, guys.
Yeah, format. I mean, there might not be a pretty way to print it. That's the thing. I didn't think there was. That's why I can't remember. Let's try bigger matrix. Yeah, you gotta do some crazy stuff.
Yeah.
Actually, let me just have like, is there like a grid of numbers? Maybe
What are we trying to show right now?
you wanted to see how this is getting sliced, right?
Yeah. I think maybe we could do it here. I think it might be clear on just on the terminal.
Okay. The thing is, I don't know how to print. Okay, or let's just try it. Yeah, let's just try it.
Yeah.
From here. So you guys can kind of see like it's not nice and formatted like vertically. I was hoping we could like because this is a 4x4, 4x4 two-dimensional matrix.
Yeah.
Because we have a list of length 4, and each of those there's a list of length 4 in those. So it's like a 4x4 box actually if we layered these on top of each other.
Okay.
But we can actually slice, like I said, using the comma and colons.
Somebody said np.array. I'm not sure if
np.array.
Have you heard of
That's
that?
what it is. Yeah, you just print np.l.
So thank you, Kodeep Joshi,
or
for
print.
that. So he says np dot array and then open parentheses and then square brackets inside.
Wait, what? No, I know what he's saying. It's coming back to me.
Yeah.
Because I haven't used NumPy in a few weeks, so I kind of forget it. Can you type it? Is it in the
Oh,
comments?
you could do 4-line in array.
But I don't know. I don't want to iterate over it.
Yeah.
I think it's array.l or something. NumPy pretty print array. I mean, we're back here.
Somebody said
What did he say exactly?
Somebody
Line by line?
somebody said import numpy or numpy as np first. And then so then you'd end up doing numpy.array. So you could do
Dot
numpy.array.
array.
So do numpy.array.
Oh yeah, because you import NumPy.
So numpy.array.
Or just
No,
just
I
print it
think you
out.
do numpy.array and then open parentheses L.
There we go.
Hey,
There we go.
thank you guys. That is awesome.
I thought it was pretty print, but I mean that's the normal.
Yeah.
All right, there we go. So this is what I was talking about. We have a double two-dimensional array here.
Yeah.
4x4. So this is easier to visualize. I was trying to do from the beginning.
Yeah.
Oh God.
Guys, I think he deserves a thumbs up for that.
I'm terrible.
Oh.
We'll hire him, have him teach it.
Yeah.
NumPy master.
Nice.
I don't know why it wasn't popping up because I remember it's something simple with the array, but they're iterating through all the crap. I'm like, okay, I don't want to have to do all that again.
Nice.
But anyways, so here the way we can slice this is you can go by the y dimension, then the x dimension. So let's just slice this. So let's start with the y dimension. Let's just get the first two, okay?
Okay.
So this is the first dimension. So what we're doing here is we're getting the first element and the second element. So in this over array, we're getting the first element, which is this list, and the second element, which is this list.
Okay.
Is that clear?
Yep.
And now, so we're getting this. Now, what if we wanted to get like this 3, 4, and this 7, 8 as like the sub array of the whole thing? Then all we want to do is just pop in a it might be
Oh. I think we Aaron, no.
So this element 2,
Oh wait,
you want to go from element 2.
we're back. Okay, we're back. I think I lost you for a second, Aaron.
Did we lost the stream for a sec?
I don't know if it was.
Okay.
I think it was Skype. I think it might have just been Skype.
Oh, it just broke down for a sec.
Yeah,
All
we're
right.
good. We're good.
Anyways, so if we have the first two elements here, slicing from 0 to 2, 1,
Yep.
2, 3, 4, and the 5, 6, 7, 8, we're essentially getting these first two. The first is like elements, because 0 up to 2, but not including 2.
Yep.
Now, if we want to get this subarray, 3, 4, 7, 8, then we're going to need to further, well, actually, let's do this subarray, 2, 3, 6, 7. Okay, how would we get this out of this whole thing?
Okay.
Well, again, it's just going to be a simple slice. But within each of these arrays, this is element 0, and this is element 1. So we want to go from element 1 to element 2, but this isn't included. So element 3 will give us these two, if we say element 3, right?
Yeah.
Does that make sense, Sonny?
Yep, we're good.
So we're in this, but I think it might be backwards. Yeah, it's backwards. So when you're adding dimensions to the array, you need to actually go in reverse order. So it's going to be like this.
Okay.
So this will give us from these two to these two, and then also of these first two arrays.
Okay.
I believe.
Yeah.
I mean, it might break. Indices
Do you have
must
to
be
use
integers,
NumPy?
not two. Huh?
Do you have to use
OpenCV is built on NumPy.
Yeah, but
I mean, will they utilize NumPy?
OpenCV is, but you're inside of
Yeah, that's what screwed me up. Yeah, because I need to call the NumPy stuff.
Yeah, so it might be
NumPy dot
array.
Yeah, NumPy dot array.
L, and then you do what you did.
L. Yeah, because it's a NumPy, right? Getting turned around over and over. Still not working. I should have brushed up on my NumPy syntax before this. I wasn't expecting to show it in here. I was just gonna show the OpenCV part. But all right, okay, guys, let's investigate together. So whenever you forget code, just go to Google and figure it out. How to display NumPy subarray. I mean, it should work. I don't know why it's not working, because it was working in the OpenCV here.
Oh, maybe you gotta do actually no, something that's gonna work.
Frame, the face, NumPy array. Well, let's display the type. So this should be a NumPy array. So let's print the type. Just make sure that typing is all correct. So when we actually have
somebody said store that in a variable and then use that. So I think what we need to do is
memory thing.
Yeah, but even you see, have it as you had it before. So numpy.array, but have the square brackets outside the parentheses.
The square brackets outside the parentheses.
No, so you know what you've got numpy.array L. Yeah.
Yeah.
Do that and then have the square brackets outside the parentheses.
Outside the parentheses? What do you mean the square brackets? Like
so do numpy.array.
Yeah.
L, and then outside that bracket. So have L inside the brackets.
Yeah.
Outside the brackets have square brackets. So now on the right. So on the right, put the square brackets and do 1302. Will that work? No. So outside the parentheses.
Outside the parentheses.
Yep.
Oh, just index like this directly. I think this might actually work.
No. I was saying so have numpy.array L. Yeah, and then change them and then get rid of the parentheses. Just make square brackets there.
Oh. Dang, dude. Coding in this terminal is terrible.
Yeah. No, yeah, like that. Maybe that will work. Yeah. Hey.
There we go. Okay.
Because then you're doing it on the object that you're getting back.
Yeah, but I mean, this is also wrong. This is indexing it wrong. You get all turned around with these numbers. Okay, let's try the other way around. 0 and 2, 1 and 3. Okay. 2, 3, 6, 7. Let's see. There we go.
Nice.
All right, we finally got it, guys. So the ordering is, if you wanted to get this subarray, then in NumPy, using raw NumPy, if you're to do it, then you need to use NumPy.array, get the list. So this is because L is just, what is L? Yeah, L is just a raw Python list. Okay, so we have to convert it to an array here. Yeah, you have to explicitly convert it to an array by using numpy.array. Change this, and then once it's in numpy form, then you can index it. Like I was saying, you can't actually do this on vanilla Python.
Yep.
So that's where not enough coffee, man. I ran out of coffee.
And now, and what we're doing with that indexing is we're saying get the first and second array inside of the sort of overall array, and then we're saying slice it to get the first and second items.
Yep,
Right?
first and second in the y direction. So in the y direction, going top and bottom.
Yep.
Then we want to get the first and second. And then in the x direction, you want to go from index 1 to 3. So we're getting these two. And then from 1 to 3, it's going to be these two. And that's how you...
Benit Decal says Sonny is also becoming pro in Python. Hey, let's go.
Yeah, but not as pro as the guy that was helping me out, because I'm just here forgetting about NumPy.
Yeah,
it's been a bit, but
oh, I think we lost Aaron again.
but just treat
he's back.
this array.
I think I lost you for a sec, Aaron. We're back.
Oh my god, this internet, man.
Also,
Can you hear me now?
Want to add a comment here. So Saurav Rajput says, "Hello there. I recently joined PWJ community. It's awesome, and I'm really excited. Welcome, dude. I love seeing our own students on the streams. We can see you here. Nice. Let's carry on, Aaron."
So here, this is casting list, this Python list.
Okay, Aaron's internet is being a little janky, or is it me? I'm not sure if it is. I think it's connecting. All right, now we have
it. Did it cut the stream?
No. I don't think it's cutting the stream. I think it's it's
okay, good.
Type, yeah.
So
carry on.
Just lagging.
Don't worry, let's carry on. Yeah, we'll carry on.
Sonny?
Yep.
Okay, got it. I think it's a shoddy connection.
Yeah.
I can't hear you, man.
You can't hear me?
Okay, cool. So, no, there's a lag. I think there's a huge lag.
Okay. Oh, we've lost Aaron on the stream. Okay, so Aaron, do you want to share your screen?
Yeah, can you hear?
Yeah. Bear with us, guys. Little bit of an internet moment. I'm not sure if it's Aaron. Okay, I think we're back. I've got you now. I've got you.
Can you back, Sonny?
Yep.
All right, good. Yeah, I think there's an internet hiccup there. Can you hear me?
Oh, dude,
there was a lag before.
Yeah. So can you hear me now?
Yep. Okay. Well, what's happening?
Yeah, we just got a 50, I think it's Mexican dollars super chat from Jessica Apolinar saying, "I love your streaming. I don't have lots of professional experience in Python, although I'm fond of learning and build my personal projects." Huge thank you, Jessica. That's insane. We massively appreciate you watching this, and yeah, like keep on enjoying the content. That's insane. I love that, especially when we just had some streaming difficulties, but we're back. Nice. Let's go.
And coding difficulties.
Yeah.
I'm running on 3 hours of sleep, bro. This is not good. Why did I do this? But what was I saying? So yeah, here in the NumPy, I ironed this out. So the issue I was making was this is a Python list. So you got to make sure NumPy list. So you got to pop into the array function, and then from there you can slice in this manner. So what I want to make that parallel here in OpenCV, it's much easier because everything is a NumPy array by default. Like the frame here this is a NumPy array, so we can just slice it normally instead of having to do the whole NumPy. You don't have to actually make a NumPy array yourself.
Okay.
But I'll try not to forget that again. But yeah, so this is NumPy array, and then we slice it like this. And again, so we're gonna do the Y direction first and X direction second. So this is actually the correct way of doing this. Coming back to our application.
Okay.
So let's delete this out. And the sub frame
Yep.
using Numpy n-dimensional slicing.
Nice. Okay.
All right, that might be kind of big, but there we go. Yep, so OpenCV built a NumPy, super powerful. And going forward, this should work. So let's walk through this again, just to touch base again, because that was a long-ass tangent. These streams go on way too long, son. I just want some breakfast.
Don't worry,
But yeah, so we get all the faces.
everyone's sticking around.
We
We're good.
find the face within the frame. Yeah, I can't even see the stream because I'm just in my code, but I'm trusting you, Sonny. We have like 2 viewers, right? 2, maybe 3.
We got about 250 people, dude, watching.
Dope.
Yeah.
Lag is super bad. Like you reply like 6 seconds.
Yeah, I know.
But it's okay.
Yeah, it's just keep going. We're good.
All right, Sonny. I don't know if it's a. Holy crap! This internet, man. It's really killing us. Anyways, so I'm just gonna keep talking, and that way it's like an So we get the faces. We find the frame. We use NumPy slicing to get just the face, and then we convert just the face to grayscale.
Yep.
And then once we have just the face at grayscale, then we can run the smile detector on that little face, and then print all the rectangles around those smiles. And this out of here.
God damn it.
There we go.
Yep.
We there?
Yep, we're there.
We're there, Sonny. Awesome. So quit out. Let's run this one more time and see if it works.
Hey, dude. There we go.
Got it. Something's
slightly.
yeah, I have a bug. So
I think the X and Y
as
might
you
be
can
off.
see, yeah. So this is the one last thing I want to say. The error that's happening here is so we're finding the faces, right? We're finding the faces. We're drawing the face. We're drawing a rectangle around the face. Okay, we're drawing a rectangle around my face. That's the first step.
Yep.
Second step is we're getting the face here. So we're creating the subarray, and then we are searching for the we're making a grayscale, and then we're searching for the smiles within that face. Once we get those coordinates, those are correct. The issue is we're actually drawing the rectangle on the frame instead of on the little face. So the reason here is we're getting coordinates. So within the face, it's a little square, right? It's a little tiny square.
Yep.
When we run smiles on this little tiny square, we're getting some coordinates back for those smiles. Does that make sense, Sonny?
Yep. No, it makes sense.
So like, actually, it might be easier to explain here on the here. So here, holy crap. Here, we're getting the face first, and then we get the sub image, and then we want to find the smiles in here. So the thing is, because this is the sub image, the XY point is actually pretty small. It's starting from here, and we're going to say, okay, go down this much Y and go across this much X. This is the top left point, and this is the bottom right point, and we can draw this. The problem is, I was actually drawing this rectangle based on these coordinates. So this was offset way up here in the left. So it was actually taking this Y and this X and drawing it on the big frame.
Oh,
when we actually want to, we actually want to draw it within the little face. So how we fix that? I mean, this actually doesn't matter too much because we're going to get rid of it and show small anyways, but just for educational purposes.
Yeah,
and so
I think it is important.
Some of my,
I think it is important. Some people might want to show that draw a rectangle, you know?
Yeah. So what we need to do is, in smiles, when we draw the rectangle, instead of drawing it on frame, right, we actually want to draw it on the face. So we take this sub image and we draw it on the face, because before here, when I smile, see, it's drawing it like if you took this green square and put it in the top left, you can kind of see that that's where my face would be, my smile.
Got it.
You see?
Yep.
Yeah, so we're just drawing it on the wrong frame.
Right.
Now, if we go back here and we quit out, just interrupt that, then we can actually draw it on the face instead.
Nice.
So this is another thing I want to say. So the face is actually just a subarray of frame, like I said.
Okay.
But the thing is, when you slice like this, I believe you're actually just accessing the actual memory of this full frame. So you're not making a copy. You're not like saying, oh, this is a new subarray that's equivalent to like this little range, but you're actually saying, just get me this portion of memory in this weird slice, because you have direct access to the memory like that with Numpy.
Okay.
So if I change this data within here, if I change the data of the frame within here, then it'll actually change it on the main frame as well, because we're just saying, okay, this little slice of the whole frame. This editing this in here will also edit this, which means editing the face will still edit the frame. So we can draw on the face, which will work. If you draw on the face, then it'll actually also draw on the master frame.
Okay.
Even though we're not drawing on the frame. So that's
Yep.
that's how that works there. Because when OpenCV draws a rectangle, it's actually just going into the memory and just like changing the memory there.
Got you.
Yep. So now let's try it one more time. And
oh, hey,
there you go.
nice. With that said, guys, we just hit over 850 likes. Let's push that to 900. And if you found that cool,
And
and Aaron, guys, Aaron just debugged everything in front of you, so I think he deserves a smash the thumbs up button and just some
the
some
NumPy nightmare,
positivity.
man.
Yeah,
Fucking syntax NumPy nightmare.
exactly. When
That's the
you're
one thing I
live,
hate about NumPy. I wish they had some nice, like, easier syntax to, but it's all like function based. That's the one downside. But I mean, NumPy is awesome. I
yeah,
used to
dude,
use it
you
a
done
lot in
it.
school.
You fixed it exactly. So that's the main thing. Nice.
Thanks. With help from the community.
Yeah.
Shout out to whoever that was. I couldn't find it on Google, and I was like, I give up.
Nice.
Not important. Run away. But anyways, from here, now though, but I mean, this is cool. But I mean, this is kind of just like the same as face detection or car pedestrian tracking. But it's like outlining it. But I think it'd be more cool if it like just detected that I was smiling and put the word smiling underneath, because you're only concerned with smiles if it's like a face. You're like, oh, this face is smiling or this face is not smiling.
Yeah.
So I think it's cool to do that instead. So let's do that next.
Nice.
Let's quit out of here. And the very last thing we're going to do is, instead of drawing this, okay, instead of drawing the rectangles around the smiles at all, we're not even going to do that. We're just going to completely ignore drawing the rectangles. I mean, it was relevant because I wanted to show you the cool little like offset thing, how the memory is actually being saved here. When you slice, it's the same exact memory, so it goes into the same memory and changes it. But I do want to show you how to put some text. So I want to avoid another syntax mistake. I'm the master copy paster.
Yeah, I think it
There
was
we go.
massively valuable to show them how to draw the actual smile, because then it gives them context as to what we're going to do next. Yeah.
Yeah, so I got rid of drawing the smile because I don't want that there. But now I pasted this ugly looking thing here.
Yeah.
So what this is now, instead of drawing the rectangle around the smile, I want to actually draw the word smile. Write the word smile, smiling. Okay, I have it right here, smiling, underneath the little portion. So like when I go here, you can see smiling pops up for a few seconds. That's what we're going to be doing now, instead of having the red.
I think you're gonna have an error, because you said if length of smile. So go back to the code. Is it meant to be plural? If length of smiles, because you've done smiles array.
Yeah, I think so. Yeah, so length of smiles is greater than 0.
Yeah, nice.
Yeah, because let me just double check. Yeah, because down here I think I used I used smile singular. Yeah, so yep. So pretty much all I'm gonna say is, if length of smiles is greater than 0, because remember, smiles is a list of all smiles it found within the face. If it's greater than 0, which means there's one or more smiles, then we're just gonna put some text on the screen. So this is very simple. This whole thing here is just displaying the word smile at some coordinate. So similar to a rectangle, it's CV OpenCV.putText. We're gonna put text on the frame.
Okay.
And that's the first thing, the image. The second argument is going to be the words you actually want to put. So I'm just gonna put smiling.
Yep.
Or you can put like why so serious or something.
Okay.
And then next is the location, the top left point of where you want to display the text. So in my case, since I want to put the word smiling just outside the green box of the whole face, I'm going to use the green box coordinates.
Okay.
Okay. So I want to put it below it. So the x coordinate will be the same, but the y coordinate will be y coordinate plus the height.
Right, so
Okay.
I'm just gonna actually draw this as you do it on the screen, yeah, because I think it might be handy.
Why?
So carry on talking over it, and I'll draw like as we do it.
I have it here if you want
Oh yeah,
to.
yeah, yeah. We'll do it. We can
I
use
can
it that.
explain
Yeah,
it here.
yeah. Let's do that. Yeah.
Yeah. So we have the coordinates. So we know this picture is smiling, but we want to put the word smiling down here instead of having this. We want to have this.
Yep.
So if we have, we know this is a yes, so we know to display smiling. Then, but how do we get the coordinates of this? So we have the coordinates of the whole face, which is what we want.
Yep.
So why don't we just have use this top left point to figure out how to get down here? So we
Okay.
have the top left point, which is x. So we can just say at x is where you want the top left point of the text to start at x.
Yep.
But then the y point, we don't want it to start here because it would say smiling up here. So we add y, this is y,
Yep.
plus h, plus the height.
Right. So
So
here's
y
y,
plus height,
and then we're saying
yeah,
plus the height, which is this. So like y
which is
plus
gonna
the
be right
height.
here.
Yep.
And then I added 40 just to have a little bit, so it's not touching the box.
Right.
I just added a little bit, and then that's it. So this point is gonna be x, and then y plus h plus a little bit more,
Right. So you
and
guys
then
can see
that'll put it right here.
exactly. We have x and y in the corner. Just go back to that side for a second, Aaron. So we got x and y in the corner, and then we're doing y plus the height, and that gets us to the
Hmm.
bottom of the box. And then you see
Right
Aaron's
here.
got smiling exactly, but if he didn't add the 40, it would be sitting on top of the green right now, or yeah,
Yeah,
pretty much on top of it.
it
So
would
we
just
just
be touching.
yeah.
Yeah.
So we want to add 40 to basically push it past that little bit extra. So yeah, awesome, nice.
Yep, and that's really it, guys. So as you can see, that's going to be the x is the same, and then y plus h plus 40 is right there. So that's the top left point of where the text is going to start.
Yep.
Then from there, font scale is just the size of the font, so size 3. And then the font face is just the font you want to use. So um, OpenCV has different fonts, so that font is called font underscore Hershey underscore plain. It's the one that looked the nicest. You're kind of limited on the fonts, but I mean, it gets the job done. And then last is the color. So BGR again, but all three are maxed out, so this will be white. Because if all three channels are at maximum brightness, 255, then it'll just be white.
Nice.
So if we run this, hopefully with no hiccups and
Whoa,
no...
before you run it, we actually just got a super chat from Velocity Trading. He says, "My
Nice.
girlfriend introduced me to your videos. She is a data scientist in NVIDIA, and she loves your content on React.js. Shout out to her, Princey Singh. That's amazing.
Nice, Sonny.
Yeah, thank you. Yeah. And look at that. How
Scientist
crazy
working.
is that? It's like two worlds came together. React.js. Now we're talking about data scientists, where the majority of data scientists code with Python. So yeah, this is dope. It's awesome.
Yeah, man. You should do a collab with her. Do like
Yeah.
a React to data science project.
Yeah.
But
Nice.
awesome, awesome. People are showing Sonny the love, the Hulk. You should you should demand people in the comments call you the Hulk. Anybody who wants to call Sonny by the Hulk, pop that in the comments right now. Going forward, we'll legally change his name to the Hulk because he can handle anything except standing.
we have Papa React. We have the React God. Now we have the Hulk.
The React God,
Nice.
React God. Nah, it's just Hulk, just Hulk. The British proper Hulk. Um, but where were we? So yeah, so we're gonna draw smiles underneath the face instead of actually drawing the box. Well, let's put both for now, for demonstration purposes.
Nice.
Let's run this. There we go.
Hey, nice. That's awesome, dude.
Yeah.
It looks a bit like that
Yeah.
horror game. You know that Slender Man. That's what the text looks like.
Yeah.
Yeah, that's
Oh,
awesome.
the Slenderman text.
Yeah, the smiling. I mean, that's awesome, dude.
And then now, if we just get rid of the, drawing on the rectangles, then it should work.
Nice, guys. If you find that cool, because it is like, look at this. Look, if now we should see no rectangle, but we should see the smiling, which means that we have that finished sort of. Hey, look at that. That's nice, dude. That's
Yeah.
awesome. And even if we have two faces on there, because we have that loop, it will actually go ahead and do it for a second face as well, right?
At will. Yeah. So let me just get.
And
I
guys,
wish there
if
was a way to get your face on the screen too, but the stream tech kind of limits that. But
yeah, let's go ahead and see it. Hey, look at that. Nice. That is awesome. Guys, if you think that's cool, smash the thumbs up button. That is awesome. And if you haven't already, and you are following me and Aaron on Instagram, go ahead and shoot us a story right now. So this is my tag and this is Aaron's tag right over here. So my tag's over here. Aaron, you just point somewhere down and you'll see it. Yeah. So go ahead and shoot a story and yeah, tag us in it and to let us know that you're watching. And yeah, we can have a chat with you guys if you found that cool. I think that's
yeah.
like it's so impressive. Like how many lines of code was it in total? Oh shit! Even when you zoom in, look at that. And guys, that's a really good example, bro, because that's showing the actual dynamic width and height changing.
Yeah.
Yeah, that's awesome. That is dope.
Cool shit, man. Cool
We almost
shit.
hit 900 likes as well, guys. That is insane. Thank you, guys.
But yeah, guys, that's pretty much the completed app. I mean, there's other things you could probably do to clean up the code. You could probably pop some of this stuff in a function. You know, I just kind of blobbed it all in one go. So not very good code design here. But other than that, yeah, I mean, we went over the using the face detectors and small detectors using XML files, which are pre-trained. If you want to learn how these actually work, then you can go watch the other streams for the actual algorithm of how that works. We captured the webcam footage. We're iterating forever until we're done with the webcam footage. We're reading every frame one by one, and then for the current frame, we are doing a quick check to make sure the frame is good to go. Then from the frame, we're creating the frame grayscale so that we can optimize it and we can speed up the process and the calculations. Once we have a grayscale frame, then we find faces within that frame. Then from all the faces, we want to actually draw the rectangle around each face.
Nice.
And then from each face, we want to create the subarray using the Numpy slicing here, which is Numpy under the hood. So we got the little subarray here, which is the same data in memory as the regular frame. So when we edit this little subarray, it's still going to edit the main frame.
Yep.
The main frame. Then we change the face to grayscale,
Yeah.
so we can run small detection on the face, and then from there, once we have that, then we can just label it as, hey, we found a smile, instead of drawing the rectangles.
Right.
So
remember, guys, what we did that nested approach for when we were drawing. Where did that happen again, Aaron? So where we avoided doing it for everything, we did it for just the smiles. It was line 38, right?
yeah.
Yep. Nice. That's so cool.
And then we put the text there, and then at the end, then once we found the face, drew the rectangle, found the smiles, wrote the word smiling. Once we've done all of that and we've edited the complete frame and all the correct rectangles and words are on the frame at the right locations, at the very end of all that, at the end of the detection, we use cv2.imageShow just to show the frame, and then we wait for 1 millisecond, and then we repeat to the second frame. So all of that's happening every single frame, all of this code.
Dude, it's insane. Like, if you actually think about it, like, let's say we went ahead and got rid of the comments and we got rid of everything. That's so little code to get that powerful functionality happening. All right, so let's actually do that. Yeah, so let's make this super optimal. Nice.
Yeah.
Guys, drop in the comments how many lines of code you think this might be. If we can do that before Aaron gets to the top. I'm gonna say maybe like 30. I'd say 30 maybe. I think it'll be like around 30. This is insane though. Like, if you was to do this kind of thing in like JavaScript, you would have to write more. And I'm a big fan of JavaScript, but I will say it firsthand. Like in Python, you can get a lot of power out of this with just having a small amount of code. So that's dope. Oh, we're getting okay near 30, near 30.
Anybody want to put money down? Sonny?
Yeah, let's do it, dude. Oh,
22, bro.
oh,
I mean,
damn.
this doesn't even count. This doesn't even count.
Holy crap, that's
And
insane.
actually, this, because it's just a break statement, you could probably get away with doing this. I mean, probably not good, but I'm cheating because I just
Yeah,
wanna. Oh,
that's insane. We have machine learning AI, everything invoked in there at like 22, 21 lines of code. So we got,
yeah.
oh, Manan Shah was close. He said that 25. Abbas Abdilia said 32. Young Ibsek
There
said
we go.
31. Guys, it's less than we all thought. Like somebody wrote one. I don't think we can do one.
I mean, just pop this in a function, just
Oh
call it
yeah,
smile
function
spell
assist.
section define.
That's insane. I love that, dude. That's so cool, man. Like yeah, that's awesome. And guys, I think this also goes to show you how. Yeah, there you go. That's the hack to everything, guys. One line. Nice.
I'm doing it, bro. I'm doing it. 1 second, just for that guy, because I got nothing better to do with my life.
I see a lot of
So
people saying like this is like calling the Haar Cascade AI isn't really AI. Guys, anything where you
boom.
have when you have a classification model that is comes under AI, and trust it, take it from a guy who's done a master's in this stuff. Like it is a like that is what we classify as AI.
Yeah,
Yeah,
if you wanna go see how these are actually generated, because we did just download this and just used it. But if you wanna actually see how you create this, like how you can train anything to like like recognize what Pepsi cans, recognize coffee mugs, whatever you want, then I explained that in the face detection video. This is like an extension using smiles, but I explained that in face detection and the car and pedestrian tracking of like actually how the algorithm actually, how the computer actually learns this. Like how the hell does the computer take an image and know how does the brain, like how does the computer use its brain to figure out what it is? So I explained that there. But it is AI because this is how computers can learn. It's not just
exactly.
random stuff.
Yeah, and that's the powerful thing, guys. Like once you have trained models, and like a lot of people, I think even in Firebase, there's a bunch of like trained models that you just have access to, which I'll be dropping some videos on. So thumbs up if you're excited for that. But yeah, like you can pretty much go ahead and use pre guys to train a model from by yourself. You need a
Takes a long
huge,
time.
yeah, you need a
Like,
massive amount of data. That's why things
yeah,
like
like
Tesla, everything gets better over time because you get more data over time, which means the model can get more accurate.
yeah, so like it's not super feasible for us to train our own. If you understand how the algorithm works and then you utilize it, that's really all you need to know to innovate. I could technically go and take like get faces from the internet, a bunch of different faces, a bunch of different smiles, and find those pictures and trim them all myself, get the data set, and then run it through some training software to do it. But then even that's just an extra step of just taking images, plugging it into this thing, and then going up. If you actually want to code up this algorithm, that gets pretty deep and nasty. I did that at my schooling at Georgia Tech. It's interesting and fascinating, but it's a big headache. So like, why reinvent the wheel? So we're doing that here. But if you want to get down in the nitty gritty, then by all means go through it. There's a free computer vision course from Georgia Tech on Udacity. You can look it up. It's called Computer Vision. They talk about all this stuff in complete detail. They talk about other object tracking like Kalman filters and CNNs, which are convolutional neural networks, which is another way to do like tracking and object detection. But Har Cascade is just the simplest way that I'm showing you because you just download this one file and then you pop it into OpenCV and it's all nice and free and easy to use. But
Exactly. Yeah.
if you do want to get deep in, you don't do like legit AI. This is like baby stuff compared to real stuff. Like even me, I haven't done too much. I haven't worked at Tesla on self-driving cars, unfortunately. I wish I have, but you can get go pretty deep. So if you want to check that out, then by all means go check out OpenCV, the OpenCV course, and feel free to like just go ham.
Yeah. For those of you who are JavaScript developers, you can use something like TensorFlow. TensorFlow is pretty much a very similar thing to what we use here, but it's not CV2, it'll be TensorFlow. And then you can actually go ahead and get models, just like the Har Cascade, and you pretty much
Hmm.
plug them into your TensorFlow and do the same thing as what we did today. So, what I challenge everyone on this stream right now to go and do is actually go ahead and like follow along this tutorial, get it working on yourself, but go ahead and swap the Har Cascade one that you're using and try and detect like an eye or something like that. That would be kind of cool.
Yeah,
Yeah.
yeah. There's literally an I one. Like if you just Google it, the OpenCV documentation or the GitHub repo, there's an I one where you can detect eyes as well. We could even do it really quickly. Why don't we just do it on the fly really quick as a bonus? I'm supposed to be done here, but let's
Let's do
because
it, dude. I'm
because I
so
actually
down.
have because I have it downloaded already. The
Yeah.
eye because I was gonna do that, but I was like, it's not important for small detection. But let's do it really quick. Okay, what time is
Yeah.
it? It's 41. Okay, I'm gonna. How fast can we do this?
Let's do it.
Boom. I boom. I.xml. I
Guys,
detector.
guys,
So what you
pump
want to
Aaron
do
up in the
is
comments right now to let him. Let's get him in the let's get him in that flow state.
I detector. So what we're gonna want to get is okay. So the face. We have the face. Face grayscale. Smiles. Smile detector. Eyes is going to be eyes will be eye detector dot detect multi scale face grayscale. And scale factor, I didn't tune the eyes, so like it might not work, but yeah, we'll see how it goes. So eyes equals that.
Yep.
Then we're gonna want to draw the smiles, and then also we're gonna want to draw the eyes. And eyes.
Yep.
And why don't we just go double? This is very sloppy, but I mean, well, actually, I can just use this because the for loops aren't overlapping. So let's just
Oh
leave it
yeah.
like this.
Yeah.
And then the eye.
Okay.
And let's just change this to 255, 255, and 255 in eyes grayscale. So this should work.
Nice.
I mean, it should. Let's see if it works.
Guys, if it works, destroy that thumbs up button. Because Aaron just done that on the fly. Like,
The eye is not defined. I have a typo somewhere.
oh, I was gonna say that, yeah, because you have the
Oh,
eye, but we need to slice it. Sorry, right?
no. I mean the face.
Okay.
That's what it is.
Oh, snap, dude.
Uh,
I mean, it might
Kinda.
hit.
I mean, mouths and eyes look kind of similar sometimes. You can kind of see. So
Yeah.
let's try to tune it. We got to tune it a little bit. Let's tune the variables a little bit and see if we can get it working better. So that's where these two things come in handy: scale factor and mid neighbors. So there's probably some ideal number. Let's just try like I don't know 1.3 and 10 and see what happens. Okay.
Yeah. It's like some Iron Man video. Okay. Okay.
Not quite. Not quite. Let's try 1.1 and 10.
Oh, we're getting there, dude. So what was the
Well,
fuck?
I just because I'm Asian, like, but if I open my eyes big, it works. I look creepy as hell, but
Nice.
like big eyes, big smile, then it can get it nicely.
That is awesome. The greatest ever says, "Let's get this to 1K likes, everyone." I think we
There
do.
you
We
go.
deserve.
Yeah, this kind of stuff.
Yeah.
This kind of stuff is what Snapchat and Instagram use on their filters. Like when you like vomit the rainbow and stuff, they're like, ah, and then when they see it, they can locate it and have it like drip down, stuff like that. So this is actually what's going on behind the scenes when using a Snapchat filter like the selfie camera, and you have like the crazy filters over your face. This is what it's doing behind the scenes. It might be using convolutional neural networks instead of hard cascades, but it's the similar principles.
Yeah. They would have a model that's already sitting there, that's already ready, and it's just the input would be the camera that you're seeing, output being that little tongue emoji or like dog thing, whatever you're using. Yeah. Nice.
Yep, that's
That's
it.
dope,
4K
dude.
smile. And about what? That took 4 minutes to get the eye up and running.
Yeah.
So it's the power of Python and having pre-trained model. Of course, if you trained yourself, it's going to take hours or days or weeks if you have to get your own data. It depends where you get data. If you're taking your own photos with your own phone, it's going to take forever.
Aaron,
Or you can just use what people have done.
you got some good comments coming in. It says, Aaron, you are awesome. Aaron
Thanks.
OP. We got a
Apparently
few.
not a Numpy.
Nice.
Whoever in the comment, I don't know who you were, but thanks, man. You saved my ass, man or woman, whoever that was. Much appreciated. I could stop embarrassing myself.
The greatest ever says, that's amazing information. I'm gonna squeeze that in when I'm being interviewed. That's awesome,
Nice.
dude. That will impress them. Yeah, I will impress
Yeah,
them.
this is a real smile. Look.
Look at that. It's so funny when that is nice.
And we could even be like we could even like have it dynamically changing, like smiling and wide-eyed, like or un-Asianified or something. You know, it could be like smiling and have like another piece of text like un-Asianified underneath. Let's do that.
Dude,
I
you know
really
what you could do? I reckon there's probably some kind of model there which tells you the ethnicity of someone, and then you have the sensitivities based on ethnicity.
that'll be hilarious. But let's just
Yeah.
here, let's just look at this code. If length of eyes, I mean, is that racial profiling? Is that like racist?
No, I
Um,
mean, no, I mean, we've got one. We got one Asian. We got one brown. You
Indian,
know.
un-Asianified. Let's just do.
So literally, the greatest ever just said unasianified.
There we go. Here, let's try
Saurabh
it. Let's try
Singh
it.
says, "Aaron, you're a good teacher. I like it. Nice."
Oh wait.
Hmm.
I think we need to tune this a little bit better. To eyes needs to be maybe 20. Let's try this, and this is way too much. Let's try 90, and quit this out here. Ah, that's
That is
hilarious, bro.
that is dope. I love that.
That's. I think we gotta tune it a little bit more. Let's try 30. Bro, I'm so late. I'm supposed to go work out with my friend, but I was supposed to leave 20 minutes ago. But the Numpy thing, really put a cog, but whatever.
Oh man. Oh wow. Tala Shah says that's the most amazing live video of programming ever. We love that, dude. That's insane. Look at that.
That's hilarious with the eyes, bro. And look at the light on my face better. Oh, that's so funny. I'm having so much fun with this, man. I wish I could send it to you, but yeah, I do gotta get going.
No, that's
Um,
cool, dude. You've crushed that.
yeah.
And we didn't even plan on getting the eyes done, so we got the eyes in there.
I mean, yeah, that's the power of pre-trained models. They also have like dog and cat. Let me just pull up the OpenCV real quick.
Yep.
Where did my Chrome go? Oh, it's in full screen. So if you just go to OpenCV, har GitHub,
Yep.
then you go here, har Cascades. They have all these pre-trained. OpenCV is like open source, so it's free and low weight. The algorithms and stuff they use at Facebook and Snapchat, like and Instagram for real, they're trained even better than these are. That's why they're so much more accurate. These are just kind of like halfway there, but they're also like pretty old. But here's the eye tree eyeglasses. I don't even know what this is. This is the frontal face default we're using for frontal face. There's other frontal faces. See how much is frontal cat face, full body. This is what we use for the pedestrian tracking.
No.
Um, for cars, I had to download a har XML file from somebody else. It wasn't provided by OpenCV, but you can find other trained models too. Like once an XML file is created from any object detection, then you can just download and use it for yourself. So like here, like this is literally what I typed in. There, har Cascade XML file. I went here, I clicked on it, and then I literally just downloaded the XML file. From it's somewhere linked in here, but you can find the XML file once you find it. So like literally it could be anything. It could be like what else? What else besides car is cool to identify? Um,
Um.
har Cascade file. I mean that one might not exist, but the
I mean,
idea is
yeah.
here soccer ball cascade. So yeah there soccer ball cascade.xml, and then so this could probably detect soccer balls in a video.
Nice.
Without a video or something like that. So like it's generic object detection. You can detect any object, any arbitrary pattern
Yep.
in a frame. So
I
that's
mean,
the power of that.
using
Go down.
using what Aaron just showed you there, you can easily detect like some balls, like on the screen. I was
Like
like,
are your balls round like a soccer ball,
yeah.
or are they lopsided like a rugby or football, American football?
Oh man.
Yeah, but here there's hard cascades. There's also some here. There's hog cascades. So hog stands for hog is like another way to do it. It's like optimization for har or something. I forget what it stands for, but it's another object detection algorithm thing
Yeah.
that you can use. But here we have all these, and then there's cats and or if you go into hog, what is in here? Pedestrians. Okay, but yeah, guys, that's it. Smile detection and Asian detection, Asian person detection in Python.
Awesome, guys. If you guys enjoyed that, let's give Aaron a massive thank you because I think he crushed it today with that. And even I learned so much with this tutorial today. So like, I thought it was cool.
Well,
Thank you, Aaron. That was amazing, dude.
you're welcome, Sonny. Thanks for streaming for me because my computer's a rock.
Saurabh Singh says, Aaron and Sonny looking for some more in the future. Cheers. Yeah, we'll definitely
Yeah,
be doing more. That was fun. That was fun.
definitely. Yeah, I am planning on doing some TensorFlow because I've kind of exhausted this OpenCV stuff. We got 3 streams on it, but I do want to get into TensorFlow, maybe even PyTorch,
Yeah.
like Sonny mentioned. So maybe in the next few weeks, stay tuned for that. I might have like a TensorFlow like crash course stream or something like that.
Yep.
Maybe we'll actually train a model ourselves with somebody else's picture data. I'm not going to do it myself.
Yeah.
But I'll find some online data set of a bunch of images and we can maybe train something and you can watch the neural net get created and then we could do something like this again.
That would be dope, dude.
Pretty
That would
cool.
be awesome. Yeah. I think also worth mentioning, guys, for anyone who joined and maybe missed this in the beginning, um, Aaron, what's lingering in the description right now? What
Yeah.
value? Yeah.
So yeah. If you guys like coding in Python, if you enjoyed this and want to do this for a living, then that's what we do at Clever Programmer. So we teach people how to take their coding skills and make money from it. As web developers with JavaScript, as Python developers, Python freelancers, whatever it is you want, like automating stuff with Python or whatever, then go check the link in the description. There's a free training that teaches you how to do that. And then there's also a full-blown course that you can join if you want to invest some money into that and time and actually pursue becoming a Python developer as your career choice. If not, then feel free to enjoy our free content. That's what this is here for, and make Asian stupid ass apps like this.
Yes.
Un-Asian.
Unasianified.
Yeah. My mom would smack me like, "Yo, respect your culture." Okay, mom. I love you, mom. You eat your rice. Yes, mom. Yes, I eat. You get A plus. A minus means death. Yes, mom. Oh, yes, yes.
Oh
And then I
man.
dropped out of school and she killed me.
That's truly unasianified then.
Yeah, that's the truth, isn't it? Yeah, we're all dropouts here, aren't we? Yeah.
That's awesome, dude. I
Yeah.
think if there's Aaron got any last few things you want to add. Oh, and we also got a donation. Thank you. Saurabh Singh just dropped a nice little donation there. Appreciate that, dude. And lots of wicked comments coming in. Yeah. Nice.
Yeah, last thing would hilarious would be actually get rid of the boxes,
What was that?
and then it would be hilarious to get rid of the boxes and just have like the full clean app. Let's do this last demo because I'm all hyped.
What was that? Let me go ahead and show it on that. There we go.
Is this racist? I'm making fun of my own race.
I think it's okay when you're the same race. It's all good.
Half unidentified. Anyways, okay, I'm gonna stop goofing around because now we're just wasting time. All right. Yeah, so if you guys want to check out the free training or the course, then it's in the description. If not, then keep watching our daily streams. I think we've been going for what, like 4 weeks now straight.
I think it's longer, dude.
Mental
I think we've gone over a month and a half now,
weeks.
maybe. Yeah.
How have we not run out of like project ideas?
Dude, we have so many project ideas now still to come. Like tomorrow's a big build. Tomorrow's a massive build coming up, so we'll be amazing to
What's
see
that?
that. Yeah, we have WhatsApp tomorrow. Stay tuned, guys. Go ahead and literally set a reminder on your phone right now for that. And we're doing that at, what is it in? I think it's 9:15 EST and 6:15 BST. That's my time. Yeah. Yeah. So awesome, guys. Hope you guys enjoyed that. And with that said, make sure if you're not following us already, go ahead and check us out. We're always posting some content. So you got me and Aaron over there, and we love to have a chat with you guys. But yeah, I
Yep.
think Aaron needs to go and hit a workout. Get some
Yeah, eat some
calisthenics.
food, some more coffee.
That's
I'm
it.
totally sleep deprived. But yeah, guys, thanks for joining me and Sunny and coding this up. It was a lot of fun, and we'll do it again in the future sometime, right, Hope?
And that's it, dude. We'll do it again, Samurai.
Alright?
Yeah.
Yeah, samurai.
Yeah.
Samurai.
That's it. Right.
Watashi wo. Okay.
Awesome.
Alright, guys, peace out.
Peace out, guys. Thank you. Bye.